certified US Times Higher Education World University ranking as a role model. His recent report for units on waste management in the West Asia region. Thank you, Dr. Abdul Sattar, for joining us today. In this session, we will have some interesting invited talks on variety of topics. The title of our first invited talks is Smart Energy Efficiency System on Chip for Next Generation Biomedical Device by Dr. Wala Sadeh. Dr. Wala Sadeh, Assistant Professor at Western Washington University, who received an MSc and PhD degree from Masdar Institute of Sciences and Technology. Dr. Sadeh's research interests include ultra-low power wearable devices and system-on-chip design for portable biomedical devices, and she has been recognized with multiple awards for her contributions to the field. This speaker will present virtually, so please give a round of applause.
Hello, good morning. Thank you for the introduction. Can you hear me well?
Yes, ma'am, we can hear you.
Yeah, should I start?
Yes, please.
Yeah, thank you. Smart energy efficient systems on chip for the next generation biomedical devices. This is a brief outline of my talk. I will start with the motivation and the research contribution. Then I'll discuss a few of my research projects, and then we'll conclude this talk with the summary. So if we want to discuss and talk about the current health diagnostic tools, we have basically the in-hospital devices that they are used to monitor the patient's conditions. For example, we have the vital signs machine that's next to the patient's bed to monitor their vitals. We have the ECG recording that attached electrodes to the patient's body and monitor their ECG signal. We have similarly the EEG acquisition system. These are just examples. So these systems, they basically are used in a hospital environment. They have limited capacity, so we have certain number of these devices available in each hospital. Additionally, they need to be operated by a clinician, which makes them more susceptible to human errors. The other option that we have is the portable devices, and I think the most common one is the glucometer, which they are used frequently by diabetic patients. So these devices, they are available to use for wide range of patients. They are providing the patients with a few readings per day. However, they are not wearable. They cannot be used for continuous monitoring. They have limited functionality. So for example, the glucometer can only be used to measure the glucose level. It cannot be used to measure the heart rate or the oxygen saturation in the blood or even the blood pressure. So for that, we need to have more specialized devices, which makes then the cost of those devices go much higher. And the picture does not get complete without access to lab test results. And for those, basically the patients, they need to go to the hospital or to the clinic, and it takes time to get the results from the time when they submit their samples. Additionally, these tests, they're mostly invasive. They require withdrawing blood samples or other types of tests. And in most cases, they are also costly. So in this aspect, my research aims to develop an smart on-chip biomedical devices that they basically help the physicians and reduce their load by providing more uh, efficient tools to detect several conditions of the human health by also eliminating human error and providing quick response. However, this does not come without challenges. So, for example, we have different disease conditions that they have different requirements. So, what is considered as a normal pattern for a certain disease is different for another one. And we need to understand how these diseases basically affect our normal biosignals. Additionally, there are patient-specific requirements. So what is considered as a normal pattern for certain person, it can be abnormal for other. Additionally, even for the patient themselves, basically at young age, their pattern is typically very different from when they are adults. So we have to be aware of all these changes. There is also an important challenge that the data availability is also a huge concern. So, for example, when we want to use these data to train, we really need to access to a large amount of data, and these can be very limited. They are not available. We need to basically record these data, and it's a time-consuming process. My also basically main goal is that to provide patients with not only intelligent artificial devices, but these devices, they should be really intelligent. And an important concern, which we are really looking to resolve these issues with powering these wearable devices. These devices basically, an important aspect of their use is that they should be having a long life of operating, so the patient, they don't have to be frequently changing the battery of those devices, which can be really an annoying for the patients and bottleneck for continuous monitoring. So we aim to have a long life of those devices so that provide patients with ease, and it also reduces the cost of devices. So we aim to use energy harvesting for powering these devices. However, we have certain challenges that we need to tackle when we are working with the energy harvesting tools. And just to mention a few of them, that these energy harvesting sources, they are usually weak and unstable. They also have limited efficiency. So we need to create the designs that they basically able to resolve these issues with the energy harvesting tools. Let me talk more about now my current research projects. So basically, if we want mainly to discuss the wearable devices, we know that wearables, it means that whatever the subject can wear. And they usually and mostly aim to help people to better monitor their health status and keep track of how the health is changing at the home environment without the need to go to the hospital. Additionally, with the current improvement in these devices, we are able to record the data at the home environment, and those data can be accessed by clinicians, which give them a better understanding of the patient's condition and allow them to tailor the treatment plan and diagnose the disease more efficiently. Now, what we require from these wearable devices in order to allow continuous health monitoring, we first and the most, we want them to operate for long time. So we want an energy efficient operation that allows continuous monitoring, and we want a long battery life. Since the patients, they are also going to mostly use multiple sensors, we need them to be in a very small size so that they don't disturb the daily routine and the daily activities of the patient who's wearing them. We mainly also want them to be in low cost devices so that they can be adopted by wide range of the people. We aim for these devices to provide high quality and reliable data that can be trusted by both patients as well as the doctors. And we need them to be personalized to understand the needs for the subject or for the person who's using them and adapt to their daily routine so that they can be more efficient use for these devices. Again, to talk about the low power operation, one strategy that we usually adopt basically is for monitoring or for working with the enormous amount of biosignal is to basically think about where we are going to process these to another processing station, or we process the signal on sensor and we just transfer the results of those signals, I mean, only. We noticed that by studying this comparison between Bluetooth fully on-chip processing consumption by 27%, by 27 times if we do the on-chip processing, which is a huge saving in terms of a power consumption. The other approach that's mostly used and adopt a standby mode or and operating mode. So we operate the devices for a very short duration. They are off for the most of the time. And therefore, the overall average power consumption significantly reduces by adopting a low duty cycle of operation. So those are few of the main strategies that we use them on chip to basically reduce the power consumption. These are just examples. There are so many others that we can work with. To also operate with and aim to develop the energy harvesting is basically the goal of that is to extend the lifetime of the wearable devices and provide an efficient and sustainable way of powering these devices. There are so many options that we can basically investigate for powering the wearable device. Just to mention a few: light, vibration, radio frequency sources, and the most promising, which is currently in extensive research, is going on the thermoelectric generators, TEG ways to power the wearable devices. And for that, we really need to develop an on-chip power management unit to extract the energy and power the wearable device. We have the options of using inductor-based DC to DC converter or using a switch capacitor voltage regulator. So we are currently investigating these options. To dig deep more into my research projects, I'll discuss an example of basically using these wearable devices to provide diabetic patients with an accurate tool to monitor their glucose level non-invasively, so they don't need to withdraw blood samples to measure their glucose level. It will offer them a continuous monitoring, and this will help them to basically get better understanding of how their sugar level is changing with their daily routine and diets and how to adapt to that. The device is also designed with a minimum power and area requirements, which helps to really achieve the continuous monitoring goal. We are utilizing in this the PPG signal photopilosoptomography approach, which is an optical signal that's basically detect the changes in the blood volumes by sending two different waveforms. We have the infrared and the red lights, and then we have a photodiode on the opposite side. We can have it in a transmission or in a reflection mode. Basically, this is also, I think, very famous. The pulse oximetry device is the same technology. This device is basically used to measure the heart rate as well as the oxygen saturation in the blood. So we think if we can utilize the same device by expanding its operation to also measure the glucose level, that's going to be a great achievement. So basically, the light that's absorbed through the human skin and then goes into the bloodstream where it has a glucose molecules, that the light is being basically absorbed more when we have more glucose level. And that's how basically it's related to the glucose level. However, we did not find a direct relation between the glucose level as well as the wavelength of light that is sent through the human body, and therefore we needed to use a machine learning to figure out an exact relation. So we have basically developed a machine learning model that extracts certain features of this PPG signal. It depends on the energy content of this feature that test different combinations of these features and then selected the ones that they basically produce the best results. The first prototype of this device was basically developed on an FPGA board and a PCB board powered with 9-volt batteries. So basically, we also developed this finger clip in-house, and we were able to measure the glucose level with a good accuracy. However, this basically is not a wearable implementation, so we really needed to shrink much down the size of this device, reduce the computation complexity, and improve the wearability of the device. So we developed the first on-chip system on-chip for glucose monitoring by using the switch capacitor PPG readout circuit that operates in the sub-threshold region to reduce the power. However, this was also using the finger to measure the glucose level, which is still not ideal for continuous monitoring. So we basically here we show the measurement results, and in this we utilized an improved version of a boost converter to drive the LED, which is the most power hungry part in the system. And this helps us to achieve higher efficiency for driving the LED from a 0.5 volt supply voltage. Excuse me. We also utilized a PPG readout that replaced basically the resistor-based TIAs with a switch capacitor implementation that utilized also a correlated double sampling to reject the undesired flicker noise and amplifier offset, which helps to basically have an efficient design. The proposed system achieved good accuracy for measuring the glucose level as well as reducing the power consumption. And this was tested on 200 subjects readings. Again, the main issue with the previous design is still the wearability. So the finger location is not efficient for continuous monitoring. And that's why we looked for what else we can do. We thought of measuring then the PPG signal from the airlobe, which can be basically used for continuous monitoring if we try to create this device in an earrings form, which can be really more comfortable for the patient to use. We also wanted to reduce the computation complexity by reducing the number of features, and have a higher dynamic range for the PPG signal by using a fully differential readout circuit. So basically, again, the LED driver, we needed to operate in a very low duty cycle in order to save power, because again, to stress out that the LED driver is basically the most power hungry part in the system. So that takes a lot of focus in the design. We also tried to implement the differential amplifier with the chopping in order to reduce the noise as well. And this helped us to reduce the overall LED power by 37% compared to our previous design. The glucose prediction processor utilized 10 features and nonlinear medium Gaussian support vector regression. We tried to simplify the implementation on chip by implementing the exponential function through a lookup table, which helps us to reduce the area required for implementing this block by around 15%. We basically significantly reduced the error in measuring the glucose level by around 10%. To our previous design, we reduced the power consumption by 88% and significantly improved the overall performance while having a more suitable location for continuous monitoring, which is the ear lobe compared to the finger. Another project which we also started working on it and still ongoing progress is the home monitoring for COVID patients and beyond. So it's not just for COVID patients, it's for any respiratory disease that is basically including flu season, RSV, or any respiratory disease. So these devices basically, this device aim to reduce the burden on the hospital as well as the main issue was during the COVID time is the patients who are quarantining at home. They did not have a mean or a single device that tells them how their symptoms are progressing and the need, what is the right time to go for a hospital. Additionally, there are hospitals were so much crowded and there is a huge burden on the healthcare system in general. So this device aimed to basically monitor the oxygen saturation in the blood, the temperature, blood pressure, respiratory rate, the breath rate, heart rate, and the heart rate variability. All of these vital signals are monitored in a single device that then going to be monitoring the patients and tell the patients about the right time that they need to go to the hospital. So we started working on this device by developing a PCB module in addition to a vital monitoring app on a mobile app to help the patients to really view their symptoms and give them an indication when it's an alarmic condition. So we have developed the first then on-chip PPG vital monitoring by developing a current to digital converter to read the PPG signal. And then we developed a vitals extraction processor that offers vital monitoring with less than 2% error for all of these vitals that we are monitoring. So the vital basically monitor, it depends on extracting periodic changes in the blood volume, which is related to the heart rate. It also monitors time interval between those consecutive heartbeats, and that's related to the heart rate variability. The difference in the absorption pattern for the oxygenated and deoxygenated blood tells us information about the SpO2, which is the oxygen concentration in the blood. And then we also monitor the amplitude and frequency changes in the PPG signal, which related to the breath rate. So all of these vitals are very crucial to the patients suffering from any respiratory disease. We were able to implement this prototype system in 180 nanometer CMOS process, and we reduced the power consumption of the device by more than 35% and 70% compared to the state-of-the-art work, with an error in measuring these vitals with less than 2%, which is an excellent achievement. So we were able to also develop a dedicated algorithm for measuring those vitals from the PPG signals. So one important, which we focused on, is also how to measure the blood pressure from the PPG signal, which is also, there is no direct relation between them, and therefore we needed to go for artificial neural network that studied basically the spectral and temporal features from the PPG signal, and we have tested this algorithm on a publicly available database, and we were able to achieve excellent results. To monitor also the breath rate, or how many breaths per minute from the PPG signal, we study how the respiratory activities is basically modulating the PPG signal, and this happens through intensity variations, frequency variations, and amplitude variations. So we needed to study a quality index that tells us how these modulation. So the aim of this basically work is to envision a biomedical targeted circuit design work that helps to solve the real life health problems and beyond challenges. So I aim with my research to equip the next generation engineers with the motivation and the skill that allows them basically to go beyond this research, and helps to develop solutions for those critical challenges that they are very important for patients, their families, and the society in general. The research basically of this mostly was developed at LUMS. So my research group have published in the top conferences, as well as top IEEE transactions. This work, please refer for more extended description of these research projects in the publication. You're also welcome to contact me to get more details about it. And we certainly need to acknowledge the funding agencies, the HEC, Islamic Development Bank, LUMS, NCAI, National Center of Artificial Intelligence, for funding all this research work. And I would also like to thank you for giving me this opportunity to talk about my research today. Thank you very much, and I'm open to questions.
Thank you so much, Dr. Balasade, for your informative talk.
Thank you very much. Thank you.
Okay, so the title of our second invited by Professor Akhtar Kalam. Professor Kalam is an accomplished electrical engineer who is a professor and former deputy dean at Victoria University. He has graduated from multiple prestigious universities in the UK, US, and India. He has authored numerous publications, books, and paper during his 27-year academic career. Professor Kalam is also a fellow of member of the Institute of Engineers in Australia, UK, and US. He has been a part of MCCM in 1989 and currently serve as the chairman and director since 2005 and 2002 respectively. Additionally, he has been an independent director of MCCAAM since March 2009. This speaker will present virtually, so give a big round of applause. I think he is not joining it. So the title of our third invited talk is Building Integrated Photovoltaic, a Smart and Sustainable Energy Solution by Dr. Adnan Daud Khan. Dr. Adnan Daud Khan is the director at US Pakistan Center for Advanced Studies in Energy University of Engineering and Technology, Peshawar. He completed his PhD in electrical engineering from the University of Naples, Italy in 2013 and has published over 30 research papers. He has secured and managed more than 88 million PKR of research grants and delivered more than 12 keynotes invited lectures. His research focuses on sustainable energy, technologies, advanced energy materials, solar PV and PVT, solar cells for building integrated volcanics. This speaker will present physically. Have a big round of applause.
सर कोई इशू तो नहीं एक्चुअली वो अवेलेबल नहीं
Bismillahirrahmanirrahim. Assalamualaikum. I'm truly thankful to UT Lahore and the organizing team and Professor Wakar, is also my teacher, to invite me to the 6th International Conference on Energy Conservation and Efficiency. I guess this is a very good initiative of UT Lahore to organize this conference every year because it definitely strengthens the academia, university, and government collaborations to address the energy challenges. And it also provides a platform for the students and young researchers who interact with the energy professionals. So my name is Adnan Daud Khan and I'm the director of the West Pakistan Center for Advanced Studies in Energy. This is our center and it was established with the support of 6th IEEE in 2014. And the main mission of the center was to address the needs of energy sector and enhancing the economic growth of the country, innovation, research, leadership, and entrepreneurship. So there were some key components of the center The first one is the governance, second one is the curriculum development, the third one is the high quality applied research, the fourth one is the graduate and postgraduate trainings, the fifth one is the academic programs, and the sixth and important one is the sustainability. So based on our achievements, the KP government has declared our center as energy think tank and focal entity for all energy related matters. So today's topic is on the building integrated photovoltaics, smart and sustainable energy solutions. One of our research groups in the center is working on VAPV systems. So I will not go much into the technical details of the VAPV systems. I will just give you a brief overview. So we know that the global demand for energy is increasing very rapidly due to population growth and economic development. So cities consume more than two-thirds of the world's energy resources and are responsible for around the same share of carbon dioxide emissions. The buildings alone are responsible for 35% of the global energy consumption and approximately 38% of the carbon dioxide emission, which include. And this figure would be doubled or tripled in the coming few years. So the buildings and the construction sector is a major source of the greenhouse gas emissions and must urgently be decarbonized through a triple strategy of reducing energy demand, decarbonizing the power supply, and addressing buildings materials carbon footprint. So, as per new policy, this is actually a European policy. All new buildings that will be occupied by the public authorities should be nearly zero energy rated. This means that all new buildings must generate their own energy using renewable energy sources, and they should not be dependent on the conventional fossil fuel generation. Therefore, integrating photovoltaics in buildings represents a feasible solution towards energy efficient buildings, and in order to achieve sustainable goals, harvesting the full potential of the building for renewable energy generation is required. So this leads us to the concept of VIPVs. So VIPV systems, building integrated photovoltaic, is the integration of photovoltaic into the building environment. So the traditional building environment, such as windows, walls, or roofs, that will be replaced by the PV panels. So as I said, through this technology, the building materials such as facades, roofs, walls, corridors, canopies, and many such large and small spaces can be transformed into sources of electricity generation. Therefore, it is a space of saving technology. So, VIPVs modules actually serve dual function of building skin by replacing conventional building envelope materials and also power generation. Now, the incremental cost of VIPVs is reduced and their life cycle cost is improved due to the fact that the cost of the conventional material is avoided. Therefore, VIPV system can potentially have low cost compared to PV system requiring dedicated pumping structures. So, VIPVs reduce pollution and improves the living standards through on-site energy generation. And as I mentioned, there is a growing consensus that VIPV systems must be the backbone of the zero energy building. So zero energy building is a general term that is applied for buildings with zero net energy consumption and zero carbon emission annually. Therefore, zero energy building implies that the energy demand for the heat and electric power is reduced, and this reduced demand is met on an annual basis from on-site renewable energy. So, here are some important EITB products, which includes the solar roof shingles or the solar roof tiles, the flexible solar panels, the roof integrated PV systems, and the transparent solar glass. So the solar roof tiles, also known as solar shingles or solar slates, they are usually based on the monocrystalline and thin film solar PV systems, and they are aesthetically pleasing. They provide clean and free energy, and they save the energy bills and also increase the property market value. But at the same time, this is a quite expensive technology. The initial cost is very high. They are less efficient than the bolt-on solar panels, and they cannot be installed on existing roofs. So this means that we can install the solar tiles on new buildings, or on those buildings we can easily replace the conventional tiles by the solar tiles. So they are not recommended for everyone. There are a few companies in the world which are making these solar roof tiles: Tesla, the Integra, Certainty, and the RGS. Then qualification.
Follow the timing mismatch, so we started the third talk, but the second talk is from Australia. Speaker is available, so it's going to start now. We'll continue with the talk at 9 Friday.
The title of our second invited talk is Smart Power Grid in the 21st Century by Professor Abdul Kalam. Professor Kalam is an accomplished electrical engineer. He is a professor and former deputy dean at Victoria University. He has graduated from multiple prestigious universities in the UK, US, and India. He has authored numerous publication books and papers during his 27 academic career profession. Professor Kalam is also a fellow and member of the Institute of Engineers in Australia, UK, and US. He has been a part of MCCA since its inception in 1989 and currently served as the chairman and director since 2005 and 2002 respectively. Additionally, he has been an independent director since March 2009. This speaker will present virtually. Give a round of applause.
Assalamualaikum, Dr. Saab, can you hear us?
Dr. Uttara, kindly unmute yourself. Dr. Uttara, can you hear us? Kindly unmute yourself.
I can hear you. Can you hear me?
Yes. So please go ahead. We just introduce your talk.
Just a minute. Can you see my screen? Let's get the screen sorted out.
We see your video. If you share, kindly share your screen.
Can you see my screen now?
Yes, we can.
Now, can you see one screen or two screen?
Two screens. Yeah, these are two
Just
screens.
1 minute. 1 minute. I'll make it one screen. Can you see one screen or two screen now?
It's fine now. It's one.
Oh, good. That's it. Now you do whatever you want to do.
Please go ahead.
Right. Good morning, everyone. This is Akhtar from Victoria University, Melbourne, Australia. And today I'll be talking about smart power grid in the 21st century. Welcome to all the colleagues and delegates to this wonderful conference. And welcome to those from overseas who are visiting Pakistan at the moment. Assalamu alaikum wa rahmatullahi wa barakatuh. I'll start my presentation by telling you that DR, which is distributed resources, is becoming a huge factor, much beyond what is their impact today. It's no longer a scenario where you compare DR to central station. Believe me, my friends, the world today is full of opportunities, except that we have to look at it from a different angle. So today, my presentation, I'll start with the future, talk about the current energy situation in Pakistan, the available option, look at some smart energy scenario, and what we have vision in Australia, I want to share it with you, some hurdles, opportunities, and challenges, and summary. My friend, this is what is happening in Pakistan today. It says over there, घंटों बिजली की गैर एलानिया लोड शेडिंग ने शहरियों को अजियत में डाल दिया. There is a huge problem in Pakistan. This is not a small problem, it's a huge problem, my friends. Look at it. The shortfall is 7,000 megawatts and more. Most of the urban cities have no power between 4 to 6 hours and 8 hours in rural cities. The demand is 28,500 megawatts and the supply is 21,200 megawatts. If you subtract 28,500 from 21,200, you get something like 7,300 megawatts. Where do you think this 7,300 megawatts will come from? It's not there, my friends. There's no power. Therefore, there's blackout. So you cannot blame the electricity company in Pakistan for such type of situation. There are many situations which is happening today. You've got power plants in Neelam, Jhelum, Gadoon, Shaiwal, Jung. They're all being shut down. And they're saying it's all on technical grounds. Fundamentally, you do not have the supply of oil and gas to run your power station. Very simple. If you do not have that, whatever the reason, and I don't want to go into the politics of it, I'm just talking about the fact of the matter that the power plants in Pakistan are shutting down. Last year, NEPRA decided to increase the power tariff to consumers by $11 per unit. And this was said in July 2022 that they have to do some fuel adjustment. Believe me, my friend, from next July, your basic power price will be 24 rupees 80 paisa per unit. If you are having trouble paying 11 rupees a unit, what will happen to the customer, the consumer in Pakistan, who will have to pay 25 rupees per unit? And they have to pay that from October 2023. Let us look at the consumption and the growth. This is the consumption of electricity. And the growth, look at the growth. Up to 96, there was substantial growth in the electricity sector. So any consumption could easily be taken care of. But after this point, if you look at this point, the growth has completely gone down and the consumption has shot up. I'm not blaming the consumers. The consumers have the right to electricity. The growth is not there, whatever the reasons, as I told you. Now, let us look at the situation, and I told you the future. Now I have this problem. This is a very simple RJ11 connector that you're seeing, an RJ11 connector. This is a very simple device that we used to do in telephone installation. And when I go to Pakistan, the first thing I do in the hotel is to find if there is internet capability. If I don't have internet capability, is this RJ11 there so I can run my office from there? And therefore, I can assure you now that we have got that every one of us will be connecting through internet. Everything. I can run my office from Lahore instead of staying physically in Melbourne without anyone knowing it. There will be no difference at all. Just like I am doing this presentation to you sitting in Melbourne and you in Lahore. And there are going to be a lot of technological breakthroughs. Some of them I want to mention: hydrogen economy. Be surprised, I'm running a lot of research in hydrogen economy. I've got 4 PhD students working in the hydrogen area. Fuel cells, I had 3 of them who completed their PhD. Smart electron products, with the coming of power electronics, huge amount of products which have come up, and a lot of breakthroughs have come. So my friends, all those who are in this room today, know please, a smart grid is a reality. But I must tell you one thing, new technology alone is not the only story. Recombinant technology is becoming a thing which is prevalent in the marketplace. The internet's success comes from 4 related but unrelated development. Lacking any of these, and the web as we know it falls down. The first one, has the government got any program for universities like UET to trade information? Is there a will to spread personal computing? Is the consumer willing to allow credit card over the web? Remember, some time back, we were scared of using credit card over the web. Now, I have hardly been to the bank in the last 4 years. See, you're doing everything on the web. But now, with all the cyber security, we're having a lot of fraudulent occurring in the banks too. So that's not very safe, but that's what is happening. My friends, I don't know about y'all, but I'm a very busy person. And I have my program for the day and I run with my diary. So it's very important that the work itself and missing the work means losing dollar. So we cannot afford. So now we have got a lot of computing, a lot of smart houses, a lot of flywheels, a lot of internet. So there is recombinant technologies available everywhere. So the market is huge. We're talking about $1.3 trillion market. You'd be surprised. In that $1.3 trillion, majority of them are finance and purchasing companies. We are very much here. We are only 1/3 of the equation. We are not even 2/3. So remember, this is a huge global market worth millions of dollars. It is not just the commodity component. Then after that, I want to mention to you that you and me are in a unique position that we can shape the future. Remember, my friends, remember, okay, technology is a small part. The market will make it happen. The business will where the investment will come from. So there has to be simultaneously development of markets, technology, and business model. Unless and until the three of them combine together, this will never happen. Now, let us see what are the competing forces. As I told you, the market is in a very critical situation as far as this technological innovation is concerned. So we have to make sure that we have got appropriate codes and standards, we have got business partnership, and we are working with cross-industry forces. This is very critical at this juncture. A lot of opportunities have come with deregulation. Okay, there are a lot of opportunities, but sometimes new entrants who are trying to enter into the field, they are finding difficult because the regulatory body are not very favorable. I remember the story when I was in Pakistan some time back in Islamabad, and at that time we were looking at making those mini power plant and using hydro scheme. And the biggest barrier that we found was WAPDA. I'm not saying WAPDA is bad. I'm just telling you the barriers are there. We have to remove these barriers. The regulation has not kept up with the changes. Markets have moved ahead of legal issues, and the market is in turmoil, my friend. There is pressure on cost, like I told you, 25 rupees per unit. And this cost is going up exponentially, my friend. Today in Australia, I want to give you another side of the story. Today in Australia, it was announced that from October, our electricity bill is increasing by 20%. So it's not only in Pakistan that you're suffering. We in Australia are having similar sort of difficulty. And there are a lot of new entrants which is coming in this field. And it doesn't have to be electrical engineers. A lot of people from computer science are going to be there. A lot of people from psychology is going to be there. A lot of people from mathematics and statistics are going to be there. So I will show you how people will come. So there is opportunities for everyone. There is demand on the grid, my friend. And as reliability goes down, the demand goes up. Now there are many customers who are ready to pay the price. They're not bothered about the price as long as they can have electricity. If you think that the grid is going to become new, no, it is not going to be new. The grid will still be the same. You'll be doing adaptive way of adaptation of the grid. But the demands are new. Like I'll give you example, Australia, this is our this is the area where we are, main population is, right? The main generation is here in the middle of Australia. There has been 35% load growth. If you think the population of Australia has grown, no, it's not. The population of Australia about 40 years back when I came to Australia, and now today's Australia, the population has only grown by 5 to 6 million only. In the same time, the population in Karachi may have increased by 20 million. What I'm trying to say, although our population has not grown, but our load growth has grown. And this has required a growth capacity of 18%, and the wholesale transaction is 400% growth. So the market is very, very volatile, my friend. Look at this. In 1998, the price shot up to $5,000 per unit, and the company wanted it, get it. At that time in 1998, in June 26 to 27, the company made a $500 million loss in that quarter. So, my friends, there are three pillars that I want to talk to you about. The first pillar is renewable energy, the second is storage technology, and the third is smart power grid. This is a picture of a smart grid. We have this River Yara, and these are all the things. And this is my university over here. So, if you look at that picture, you can see that it's beautiful. The question comes, and many people ask me, Prof, what is smart grid? And my definition of smart grid is that it's not a thing, but it's a vision. This is a journey and an evolution. The smart grid has to be more reliable, more economic, more efficient, more secure, more environmentally friendly, and safe. And this will make our grid enable participation by customers. Now, consumers, remember, my friend, no longer are consumers, they are prosumers. That means they are producing as well as consuming. Like myself, I have got on the top of my roof 6.6 kilowatt of solar panel, and I've got 5 kilowatt of battery. So when I'm not using that much electricity, I sell it back to the grid. I get a feed-in tariff. Now that feed-in tariff might die after a period of time, but at the moment I do make some money. My electricity bill now is $0, and I'm running my whole house. So all types of generation and storage options are there. You see, I've got solar, I'm getting electricity from our thermal plant, which will die down by 2030. Okay. Now I've got gas. There's so many options which are there. This will enable new products, new services, and new market, and they will provide power quality for the digital economy. And that will optimize the asset utilization and operate it efficiently. You will find self-healing coming in. That means for a small fault, automatically the system will heal itself. And the most important thing, it will be resilient to attacks. That means cybersecurity. And you know that natural disasters occur, whether it is cyclone, whether it is a typhoon, whether it is earthquake. You've seen what happened in the earthquake in Turkey. So many people died. There's no power even today. And the earthquake did take place more than a month back. So the smart grid milestones are: consumer becomes an enabler, distribution system is very advanced, transmission operation is very advanced, and the asset management is very advanced. So, but my definition of smart grid is that there's no silver bullet. Everyone says it's complete, not complete. I think we're just introducing the technology. We have now got outside players whom we have not seen in electricity area. Telstra has come in, Optus has come in, IT hardware and software solutions with IBM, Google, etc. are there. And specialist solution companies have come in. Cisco's, etc. have joined in. So in our country, especially in Australia, we have many aspects of smart grid, and we are improving our systems and we are adding more and more. But most of the work is in high voltage and high power. Not much has been done in the low voltage and low power. So if you define this and put an analogy of a tree, all the works are on trunks and branches, not much on the leaves. So if you want to know what is distributed energy, it includes distributed generation, energy efficiency, demand reduction, and distributed storage. All these will fulfill a broader set of goals and with a lower cost to the customer. So if the price of electricity was 11 rupees an unit, it should not have gone to 25 rupees a unit. It should come down to 5 rupees per unit if we had a distributed energy. And this has to be with a greater flexibility than the DG alone. So when I'm talking about smart grid, and we are looking at meeting the electricity demands for high security, high quality, very reliable, and available 99+% of the time. So we are looking at a smart energy, and we have to find an application of digital information so that we can optimize the electrical power system. So smart grid is basically two things: power delivery and generation and the smart energy technology. So if you look at the economic revolution in history, and that is taking power from one end to the other. So now we have got the new energy, which is not fossil fuel plant, but this could be from PV, from wind, from hydrogen, you name it, and the comms regime. I remember when I was a student long time back, we hated telecommunication. Now you can't do that. You remember that your backbone is no longer the energy, but it also is communication. And I tell you, I'll show it to you. Therefore, there is two infrastructure: power infrastructure and communication infrastructure. So let us see. This is the generation, right? We've got all these 500, 330, 220 kV line goes to the terminal station. Then you go to a sub-distribution level to 6 kV, go to the zone substation. From zone substation, it goes to a distribution system, which is at 22 kV. And from there, it goes to our industrial consumer, which is at 415 volts, or it goes to our residential consumers, which are at 240 volts. And therefore, this is our humble home that is run by 240 volts. So my friend, this is all this thing that is happening. If you look at it, what was happening is that we have onshore generation, we also have offshore generation. Okay, it's better to get offshore generation if you've got facilities. In Pakistan, you do not have too much facility. In Australia, we do have it, and we like to have some offshore generation also. Now, if you look carefully, this is a nighttime view. Look at it. You've got an integration of a lot of things coming in: remote monitoring and control of wind or solar farm. Long distance transmission line will become very, very efficient. We might be looking at high temperature superconductor cable. Renewable energy integration will be there. The wind will be offshore, not only onshore. Then we will have PV panels on the top of roof. You'll be surprised. In my city in Melbourne, which has 4.5 million people, already 1 million houses has got PV panels. And we have 33,000 only, which has got battery along with PV. So energy storage is going to be for backup power, and grid can be operating in a distributed generation. Now look at this. So you've got this offshore plant, you've got a wind plant over here. Now, if you look at it, new things are coming. The plug-in vehicle, that electric vehicle. This is going to make it a very difficult thing because charging infrastructure has to change. The grid capacity will increase. You will need new network management, that load management and real-time pricing. And you will find that you will be using V2H, that's vehicle to home. If you have got a fully charged electric vehicle, why can't you run your home in your electric vehicle. So, therefore, there is integration from supply to demand. There's integration of renewables. There's demand responses. Electric vehicles will be integrated, be very reliable. So when people think of smart grid, they think there's going to be smart meters. Believe me, it's not only smart meters. It'll include transmission and distribution. It'll include automation or IT and power devices. So in fact, there'll be a whole automation of things from generation all the way up to consumption. And all these new things will come in. I don't have the time to go through each one of them individually because of the lack of time. I want to finish it quickly so that we can get some discussions going. But look, my friend, distributed resources. When you talk about distributed resources, you're talking about interconnection of DGs. We're looking at energy storage, interconnecting that. We're looking at power grid management, that is real-time monitoring. You do the automation on the transmission and distribution system. You look at the DR and the comms. As far as the customer is concerned, on the customer side, there'll be smart meters, there'll be smart buildings and equipment, there'll be smart appliances, and there'll be customer voltage regulation. Now you will say, what is the benefit to Pakistan? Why should we go and spend so much money in making our grid smart? First of all, you're adopting new technology. Second thing, there'll be a huge amount of jobs. There are so many Pakistani youth that I meet who do not have jobs. This will be a great accelerator for people to get jobs because the old engineers will not be suitable for the smart grid. They will not be able to handle the smart grid. The cost of electricity will be down. The country will be in a happier situation where they don't have to pay 25 rupees per unit. Blackouts and brownouts will not be there. Today in Lahore, you're having 4 to 6 hours blackout. In Multan and other places, you've got 8 hours blackout. My friend, this cannot go on. You cannot tolerate such type of electricity because you have become so much used to electricity that you will not be able to tolerate such blackout. Your progress will be hampered substantially if you have these type of blackout. That means half a day you cannot work because of this blackout. Efficiency will improve. Pollution, this is a great thing. Pollution will disappear. And this will promote the growth of distributed and renewable resources. So, if you look at my vision of the comprehensive deployment of advanced electrical power, the question is that who's going to pay? Naturally, the customer has to pay. Power distribution will become automated. Power generation will be added. So all the local power generation, all of us who are generating power, who are prosumers, will be adding to the generation. And as I mentioned, jobs and skills will grow. So this is my traditional grid. If you look at it, this is how the power is produced from thermal station or hydro station, and it comes to individual houses. Now we bought in renewables. Now we bring in renewables. Look at that. We are integrating renewables. So I've got renewables. I've got PV. I've got wind. I've got PV on the top of the roof, and I've got wind turbine. I've got onshore as well as offshore. So I'm integrating my renewables. Once I've integrated the renewables, then I see that I've got a system where I've got PVs, I've got wind, I've got hydrogen, I don't know, waste to energy, I don't know. There could be n number of the nuclear, whatever you have got. So you will have a situation when you will have a situation in Pakistan very similar to this, where there'll be a lot of renewables, there'll be huge amount of clean energy being produced, and you will cut down your pollution substantially. And this is what is smart grid, my friend. which will be a combination of technology. So, what is the difference between the traditional grid and smart grid, which is the future grid? Look, I told you that this is centralized power generation. Look over here, so many different places that we have got power generation in our future grid. Here, look at the traditional one. The power flow is one direction. Look at the power flow in the new grid. It is flowing everywhere. This is built on historical experience, okay? And this one, the load is adapting to production. And there's limited grid accessibility for new producers. Whereas here, you can keep on adding modules after modules, and more people will come in. So in fact, what I'm having is who are interested in smart grid. If you look at it, this has become a political issue. I mean, I see Biden talking about it, European Commission talking about it, a lot of political leaders talking about it. This has become a political target. Smart grid has become a political target. There are a lot of governments, departments, parliaments, regulators. In the legal framework, you've got utility CEOs, boards, investment plans to support business target. And all of them are giving technical solutions to achieve political and business target. My question to you is, where is UET over here? I can't see UET. Where is the University of Engineering and Technology, Lahore? This is where they are. This is where they are. Remember, all of you are consumers and all of you are voters. You can drop these people dead duck. So the situation is such that the portfolio from production to consumption. Production, you will be having traditional power plant, you will have solar generation, you will have wind farm, you've got distributed generation. Consumption, there'll be smart meters, smart houses, plug-in vehicle, and industry. So you will have real-time pricing. Then you will have a lot of automation. And I like this IEC 61850. I have a lot of people working in this area. Then we'll be using comms like PLCs, optical fiber, and wireless communication. Flexible AC transmission will improve the grid stability and grid code compliance of renewable. Then you will have things like SVC light for energy storage. You will have a lot of HVDC for long distance transmission. And you will see integration of wind and solar power production. And you will find out that the electrical vehicles will be including outlet boxes for charging. Smart meters will be there, industrial energy management system will be there, and the houses that we live in will become very smart. Now, if you think about this, is this in the European countries? No, my friend. Look at this in Norway. In India, they also have it. So it's not that this is a rocket science, and I can't see where is Pakistan we have this. We already have this in Asia. So this is the smart grid, this is the electricity grid, and look at the comms. Where there'll be land, there'll be wide area network, there'll be neighbor area network, and there'll be all the home area network, the building area network, and the industrial area network. So this will be your comms layer, which will be as big as the power system layer. Now the hurdles. Hurdles is that any new technology has to face this. And regulatory system is one of them, which discourages people. As I told you, I was going around with International Islamic University in Islamabad, and we were going and putting small mini dams in Islamabad. And we had a lot of issues from WABDA. Then we see the changes in regulations which investors-owned utilities will have to overcome, because any incentives that you get, will always be good for the smart energy technology. And the most important thing that I believe for UET is that you should be training your your graduates to have new grid technology, not the traditional Ghisa Pita power system that we teach. Okay, and they have to look at two critical power industry issues: power, comms. So now, after that, like to say, you will find a lot of new intelligent devices which will be very smart. Okay, you will find energy efficient innovation coming in, and you will find that we will become active participants. That means we will no longer be consumers, we are presumers. This was said by Gateway CEO, and he people thought he was joking, but I think he was not joking. He said, "Here's the deal, customer. We'll give you a house, but we want is your utility bill, your internet access, your telephone service for the rest of your life, and your children's life." Someone coming to you and say, "We'll give you a house in Mall Road or Lahore, provided you pay us the electricity bill for all your life, pay us your internet access for all your life, your telephone service for all your life, and your children's life." If you sign that contract, they will give you a house in Lahore. So now you will find that you are getting power sales by appliances. There'll be island of automation. There'll be granular management. Uh, I think I already have a fridge, which is a smart fridge. It tells me the cheese is not there, eggs is finished, butter is not there, vegetable is short. So we already have that. So there will be everyone knows our consumer behavior. My behavior is known by my supermarket, and there'll be co-marketing. It won't be electricity, it'll be gas, it'll be everything. Now, what are the technologies? The technologies are internet, distributed RM, resources, and EMS. You will find the reality is that reliability will be an issue, economic volatility will be there. There is technology which is available and it will be driven by business and customers. So, my friend, scan and understand the market, act, initiate, and try new technologies, develop new options, build appliances partnership, leverage your advantage, and prepare for a very disruptive market force. You will find that that the future is already here. You have to close the gap. You have to look at resolving the policy and market rule. So when I talk about a smart grid, I'm talking about S, which is signal processing, state estimation, stochastic generation, and self-healing. Now, the M stands for monitoring, that is VAMs, multi-energy carriers, multivariable, mixed generation, market enabler. And then after that, the A stands for adaptive, augmented, affordable solution. My R stands for robust, responsive demand, reliability ICT, renewable energy system, real-time control, reduce uncertainty. My T stands for transcontinental, tailored for individuals, tolerant to behavioral pattern and trade-off analysis. So you find this is my S, this is my M, this is my A, this is R, and the grid will become smarter, my friend. The grid will become smarter, and you have to model and operate the relaying by something which is close to real time. And you will be using a lot of state of art VAMs and integrated ICT systems and very intelligent PE devices. So, my friends, in conclusion, I want to tell you smart grids have become political target, but they are essential if we want to keep our environment clean. There will be efficient energy. You can implement smart grid in an evolution of the existing grid. A lot of things will come in form of efficiency and reliability. You will be seeing outage management on meter information. You will see a lot of fax and HVDC installation. You will find a lot of things on electrical storage, demand response, charging infrastructure with the coming of electric vehicles. In Australia, we have already decided that in 2030 there won't be any more IC engine. All cars will be electric, and industrial standardization is required. The smart grid challenges and technologies should attract many young engineers from UET to come and join our force. Some of the areas that you should look at, one area that I think you should look at is data analytics. The second area I think you look at is probabilistic modeling. And the third area you should look at is real time risk limiting control. And many of my students are working now, they're not working in this traditional things. They're looking at analytics, they're looking at probabilistic modeling. A lot of students I have now who are computer science students, who are mathematics students, who are doing their statistics studies. So, my friends, in conclusion, I want to mention that, you know, don't worry about the future. Abraham Lincoln said, the best thing about the future, it only comes one day at a time. Thank you very much. Any comments, any questions, any?
Yeah. If we have some time, if you have any question, and one of you want to ask a question. Thank you so much, Professor Kalam. It was such a
That's all
wonderful
right. It's a pleasure.
insight. Yeah. If you have any question, then I can ask a question. Professor, it's wonderful. Like we can see it's the future. It's the promising to have an integration of renewables system. And we have seen the successful example like Scandinavian countries, for example. So let's say, being born optimistic, I say everything is working fine. We have a political will. So how much time you, in terms of you visualize that we can have this like this stream of integration of renewables in Pakistan? How much time we need in terms of years if we want to have them like successfully running in our country?
Very good question. Thank you very much. I think there are enough wind capacity in Pakistan, and I'm talking about my experience when I was driving towards Mehran University in Sindh, where they have a lot of wind turbines on the road. The only bad things I saw was that those wind turbines were not working. Unfortunately, those wind turbines were not working. And that I thought was the worst thing that I could think. The problem is not the wind turbine. The problem is not the goodwill of the government. The problem is not the goodwill of NEPRA and other utilities that you have in Pakistan. The problem is that there is no maintenance of those things which are there. So that is one problem. The second problem is that, I mean, I can't understand this. I just can't understand this. Second problem is Allah has blessed Pakistan with the best renewable energy in the form of solar power. I cannot understand why 100% of the houses in Pakistan do not have solar panels. You'd be surprised if I told you in Bangladesh, even where the cows are herding and they are moving around, there are solar panels all around in that field. It is become part of the nature, my friend. And so I just can't understand why we don't have it. And I must tell you, Pakistan is blessed with the best solar power that you can find in that Southeast Asian corridor. Then the other thing which is there is that which I want to mention clearly, and and this is not a political statement, please don't misunderstand me. I cannot understand how Pakistani population is tolerating these blackouts. You will never succeed in life if you do not have 100% reliability in your electricity supply. How can you tolerate not having power from 6 hours to 12 hours a day? How can you tolerate having a shortfall of 7,000 megawatt? It's very difficult because in Australia, we have every time excess capacity, which we call spinning reserve of 25%. So we've got every time the excess capacity, 9,000 megawatt is the supply of the state, and we always have 25% more than that. And this bewilders me that why it is happening like that. I believe that Young people like you all who are attending this conference, you should be taking lead in this and change the system. You going to the electricity industry, taking lead, becoming CEO of these organizations, you will make a lot of change. I remember I was the examiner of one of the students from RMIT who happens to be a CEO of in Lahore itself, Rana Jabbar Khan. Um, he's a dynamic person. You need those type of dynamic person to be leading your electricity organization. I can promise you, my friend, you can have a reliable, renewable energy sources within 5 to 10 years. You asked me the time limit, I've given you the time. Provided there are three factors to it. There are three factors. One is the government. Remember the government. The government is a very important factor. The second factor is the business. And the third factor is the technology. I think there is, with my experience with Pakistani students who I supervise, I can't see any problem with their qualifications and knowledge. I do not have any problem. I mean, I have my friends. I had my friends in in UET. I remember Tiger Qureshi, Sohail Qureshi. I call him Tiger. He looks like a tiger, man. So Tiger Qureshi. Then there was Asghar Saqib, my student in UET Faisalabad, Faizan Dastagir. All these people, they're brilliant students that we have produced, and they're all from Pakistan. They're not from Timbuktu. So I don't see there is any problem with the education that UET is is giving. The problem is that UET should have the guts and the will to change the syllabus so as to accommodate the new form of engineers. Not that I use the word Ghisapita engineer. We are still producing those Ghisapita engineers. We are still using the same old traditional textbooks. I don't think that will be good enough. I think you need dynamic people. You need dynamic people to be leading your departments. As I told you, in order to teach smart grid, you need smart professor like Akhtar Kalam.
Thank you so much. Once again, big applause for you, Professor. Thank you.
Thank you very much. Thanks a lot for attending. All the best. And Ramzan Mubarak to all of you. Ramzan Mubarak to all of you. Assalamu alaikum.
We still have 2 talks to go, and both of us are here physically. So, but you are not asking questions. So it's better to have a quick break, tea break, 5-10 minutes. So they become wake up and come back. I will just quickly tell you. I always used to tell my students. There's a famous Chinese proverb. They say you can be a fool for 5 minutes or a fool for whole life. So they have this thumb rule formula. They say if you ask a stupid question, which you think is very strange, like my colleagues will laugh at me, you can be stupid only for 5 minutes. But if you not ask any question, you can be fool for whole life. So please, we want this like sessions to be more interactive, engaging, not like the speaker is active and you remain passive, but should be vice versa. So we will have a quick tea and then we will start our next 2 speakers. Thank you so much.
Under the auspices of the Government of the Punjab, Centre for Energy Research and Development, CERAD, established at new campus of UET, CERAD marks as a symbol of excellence in R&D activities in energy sector. As you enter the main corridor, it opens various avenues of research in almost every domain of energy technologies, and various research labs are dedicated to perform research and development activities in the areas of photovoltaic, coal, bioenergy, wind energy, solar thermal energy, hydropower, and energy conservation. Since its inception in the year 2012, CERAD has achieved great milestones under the supervision of Dr. Waqar Mahmood and his dedicated team that includes professionals with excellent academic background and industrial experience.
Center for Energy Research and Development is a unique facility in the new campus of UET Lahore. Here we have developed facilities for the validation of solar panels and some of the components which are used in solar technology. More recently, we have developed an AC testing facility within our, also focused on micro hydro turbine technology and also biomass technology. These technologies are providing solutions for the energy problems of the province and the country.
CERAD is fully equipped with the state-of-the-art testing facilities as per international quality and performance standards. In hybrid electric vehicle sector, CERAD is working in collaboration with Car USA and Casper to design and test low-cost solar-powered small hybrid vehicle. In coal energy sector, besides developing pilot-scale coal gasification facility, a coal sample bank has been developed where coal is not only collected from various mines of Punjab but also preserved in standard environmental conditions.
Coal sample bank, we collected 19,000 kg of coal from all over Punjab, and in coal processing facility we developed different techniques that is suitable for processing of this coal. Processing of coal is necessary so that we can provide an environment-friendly clean coal for safe operations.
The center is also contributing towards the knowledge-based economy. First ever postgraduate program relevant to the energy engineering in Pakistan was successfully initiated at the center in year 2012 that has produced hundreds of research scholars with professional skills and commitment to serve the society in an effective manner. It is also providing vocational training courses in solar technology, PV pumping, and renewable energy technologies under the umbrella of Punjab Skills Development Fund (PSDF) and National Vocational and Technical Training Commission.
We are providing consultancy services for the Punjab government and some for other provinces. Currently, we are in the lab where we are teaching the students of the PSDF and the NAVTEC. PSDF is a provincial level body that we are providing training for them. And in a similar case, we are also providing renewable energy courses for the NAVTEC.
Besides this, CERAD organizes seminars, conferences, and workshops on regular basis so as to create better understanding of modern technologies and awareness in masses to conserve energy.
We are trying to work on various projects related to energy efficiency and conservation. We initiated the energy efficiency and conservation course for the industries. We are also working on the solar pumping systems. We can enhance the efficiency of pumps and motors, establishing the first AC testing lab with giving all the technical support to PICA.
CERAD believes in strong industrial and academic relationship, and to bridge the gap between industry and academia, it has signed a number of agreements with industry and academic institutes. So what are you waiting for? If you are working in any renewable energy technologies, including solar, wind, hydro, biofuel, or coal energy sectors, and you need our services, feel free to contact us. Under the auspices of the Government of the Punjab, Centre for Energy Research and Development CERAD, established at new campus of UET, CERAD marks as a symbol of excellence in R&D activities in energy sector. As you enter the main corridor, it opens various avenues of research in almost every domain of energy technologies, and various research labs are dedicated to perform research and development activities in the areas of photovoltaic, coal, bioenergy, wind energy, solar thermal energy, hydropower, and energy conservation. Since its inception in the year 2012, CERAD has achieved great milestones under the supervision of Dr. Waqar Mahmood and his dedicated team that includes professionals with excellent academic background and industrial experience.
Center for Energy Research and Development is a unique facility in the new campus of UET Lahore. Here we have developed facilities for the validation of solar panels and some of the components which are used in solar technology. More recently, we have developed an AC testing facility within our, also focused on micro hydro turbine technology and also biomass technology. These technologies are providing solutions for the energy problems of the province and the country.
CERAD is fully equipped with the state-of-the-art testing facilities as per international quality and performance standards. In hybrid electric vehicle sector, Sirad is working in collaboration with Car USA and Casper to design and test low-cost solar-powered small hybrid vehicle. In coal energy sector, besides developing pilot-scale coal gasification facility, a coal sample bank has been developed where coal is not only collected from various mines of Punjab but also preserved in standard environmental conditions.
Coal sample bank, we collected 19,000 kg of coal from all over Punjab, and in coal processing facility we developed different techniques that is suitable for processing of this coal. Processing of coal is necessary so that we can provide an environment-friendly clean coal for safe operations.
The center is also contributing towards the knowledge-based economy. First ever postgraduate program relevant to the energy engineering in Pakistan was successfully initiated at the center in year 2012 that has produced hundreds of research scholars with professional skills and commitment to serve the society in an effective manner. It is also providing vocational training courses in solar technology, PV pumping, and renewable energy technologies under the umbrella of Punjab Skills Development Fund (PSDF) and National Vocational and Technical Training Commission.
We are providing consultancy services for the Punjab government and some for other provinces. Currently, we are in the lab where we are teaching the students of the PSDF and the NAVTEC. PSDF is a prevention level body that we are providing training for them. And in a similar case, we are also providing renewable energy courses for the NAVTEC.
Besides this, Sirad organizes seminars, conferences, and workshops on regular basis so as to create better understanding of modern technologies and awareness in masses to conserve energy.
We are trying to work on various projects related to energy efficiency and conservation. We initiated the energy efficiency and conservation course for the industries. We are also working on the solar pumping systems. We can enhance the efficiency of pumps and motors, establishing the first AC testing lab. We're giving all the technical support to PICA.
Sirad believes in strong industrial and academic relationship, and to bridge the gap between industry and academia, it has signed a number of agreements with industry and academic institutes. So what are you waiting for? If you are working in any renewable energy technologies, including solar, wind, hydel, biofuel, or coal energy sectors, and you need our services, feel free to contact us. Under the auspices of the Government of the Punjab, Centre for Energy Research and Development, Sirad, established at new campus of UET, Sirad marks as a symbol of excellence in R&D activities in energy sector. As you enter the main corridor, it opens various avenues of research in almost every domain of energy technologies, and various research labs are dedicated to perform research and development activities in the areas of photovoltaic, coal, bioenergy, wind energy, solar thermal energy, hydropower, and energy conservation. Since its inception in the year 2012, Sirad has achieved great milestones under the supervision of Dr. Waqar Mahmood and his dedicated team that includes professionals with excellent academic background and industrial experience.
Center for Energy Research and Development is a unique facility in the new campus of UET Lahore. Here we have developed facilities for the validation of solar panels and some of the components which are used in solar technology. More recently, we have developed an AC testing facility within our, also focused on micro-hydro turbine technology and also biomass technology. These technologies are providing solutions for the energy problems of the province and the country.
Sirad is fully equipped with the state-of-the-art testing facilities as per international quality and performance standards. In hybrid electric vehicle sector, Sirad is working in collaboration with Car USA and Casper to design and test low-cost solar-powered small hybrid vehicle. In coal energy sector, besides developing pilot-scale coal gasification facility, a coal sample bank has been developed where coal is not only collected from various mines of Punjab but also preserved in standard environmental conditions.
Coal samplement, we collected 19,000 kg of coal from all over Punjab, and in coal processing facility we developed different techniques that is suitable for processing of this coal. Processing of coal is necessary so that we can provide an environment friendly clean coal for safe operations.
The center is also contributing towards the knowledge-based economy. First ever postgraduate program relevant to the energy engineering in Pakistan was successfully initiated at the center in year 2012 that has produced hundreds of research scholars with professional skills and commitment to serve the society in an effective manner. It is also providing vocational training courses in solar technology, PV pumping and renewable energy technologies under the umbrella of Punjab Skills Development Fund (PSDF) and National Vocational and Technical Training Commission.
We are providing consultancy services for the Punjab government and some for other provinces. Currently, we are in the lab where we are teaching the student of the PSDF and the NAVTEC. PSDF is a provincial level body that we are providing training for them. And in a similar case, we are also providing renewable energy courses for the NAVTEC.
Besides this, Sarad organizes seminars, conferences, and workshops on regular basis so as to create better understanding of modern technologies and awareness in masses to conserve energy.
We are trying to work on various projects related to energy efficiency and conservation. We initiated the energy efficiency and conservation course for the industries. We are also working on the solar pumping systems. We can enhance the efficiency of pumps and motors, establishing the first AC testing lab with giving all the technical support to PICA.
Sarad believes in strong industrial and academic relationship, and to bridge the gap between industry and academia, it has signed a number of agreements with industry and academic institutes. So what are you waiting for? If you are working in any renewable energy technologies, including solar, wind, hydro, biofuel, or coal energy sectors, and you need our services, feel free to contact.
They are not recommended for every group. There are some companies which are working on these solar group types. The Tesla, the Tegra, the certain Heat, and the RGS. The second one is the flexible solar panels. These flexible solar panels are engineered to contour to different surfaces and are especially well suited to installation on uneven surfaces. It means that we can install this kind of panels on irregular surfaces. So the slim and the profile and lightweight nature of these panels make it easy to transport, install, and store. So there are three main important benefits of the flexible solar panels. The first one is the PV can be positioned diagonally in such a way that the solar cell performance would be enhanced under oblique angle irradiation. The overall footprint of the solar cell is reduced, leading to greater efficiency or power output per square meter of roof area. So they are space efficient panels. Third one is the relative smoothness of the corrugation on roof cladding allows for solar panels to be laminated without significant stress at the points of reflection. So the common products, common flexible laminates for solar flexible solar cells. right? So these panels are based on the CAGS, gallium, indium, gallium, selenide, Northwest silicon, the GSSC right hand side, solar cell, the perovskite, and the flexible crystalline silicon panels. The efficiencies of these cells ranges from 6 to 9%. So the lightweight and flexible solar film can be integrated into fabric to make hand it's applied in the Gen C relief power. So this is a very important application of these flexible solar panels. The energy technologies is one of the manufacturers in the US who are making this product. For this solar tent, the nominal rated power at the standard testing condition is around 2 kilowatts. Now, the next important one is the transparent solar panels. Nowadays, we see glass everywhere, ranging in size from small cell phone screen to huge windows and skyscraper facades. It is estimated that there are 5 to 7 billion meters square of glass surfaces in US. So imagine that figure for the whole world. We have enough glass. In most of the buildings, these large areas of glass remain in unused energy tank. Normally, for passive heating and natural illumination, the triple glazed glass is used for windows. So, what if we go one step further, along with the heating and natural illumination, we can produce electricity. So, for that, we should install a transparent solar panel. There are two types of the transparent solar panels. The first one is the partially transparent solar panel, where we allow some of the visible light to pass through the panel, and the remaining light needs to be absorbed to produce electricity. The efficiency of these panels ranges from 7 to 10%. And these panels are installed in order to reduce the sunlight levels that goes into the building. Onyx Solar is one of the leading manufacturers of the transparent solar glass. And they are using two technologies. The first one is the amorphous silicon-based transparent solar panels. The second one is crystalline silicon-based transparent panel. And their transparency ranges from 0 to 38%. Now they have made an interesting project. They have installed the PV panels. This is a McDonald's restaurant in Florida where they have installed these panels, and this become a zero energy building and the first zero emission restaurant in the US.
Under the auspices of the Government of the Punjab, Centre for Energy Research and Development, CERAD.
Transparent solar panel, and this is our dream to have a solar panel which looks like a regular glass. So a team at the Michigan State University created transparent luminescent solar concentrator which uses organic salts to capture only the UV and IR by allowing the visible light to pass. So this is the panel. When the light hits the panel, the UV and IR light are turned into different type of infrared categories. So here are the solar cells. They capture these infrared lights, infrared and ultraviolet lights, right? The solar, the role of this cell is to absorb the light, so that has converted to electricity, and the complete visible light is passed through this panel. So it looks like a complete transparent glass for human eye. However, the efficiency, the transparency is very high, 86%, but the efficiency of these panels is very low. The same company created a facade for Kansas headquarters, which is the largest Coca-Cola headquarters. They have installed amorphous gray color amorphous silicon glass modules here, and the transparency of this solar glass is 20%, and it can produce approximately 17,200 energy. This is not completely or fully transparent solar panel. So because the transparency here is just mentioned. So for the transparent solar panels or for the thin film technology, to be noted that the efficiency of the solar cell is not everything. The low efficiency of transparent solar panels means that we need a large area covered in order to produce the same amount of power as a 20% efficient rooftop solar array. However, given the transparent solar panels can be integrated into buildings, there is more potential surface area to compensate for the low efficiency. As I mentioned in the last slide, that we have enough glass available, so we can compensate the low efficiency of the panel. An interesting advantage of partially transparent solar panels is that thin film solars can achieve high efficiency even when they are not at the optimal tilt angle, which is great for buildings where windows are installed vertically. The thin film solar cells are also more tolerant to heat. However, a lower decrease in efficiency than traditional crystalline silicon solar panels may present. So these are the few advantages. Now, this is a building, and we want to integrate solar panel to most of the parts. So for example, we can use the parking shed here to install a panel. Then transparency glass starts with DATV integration. So these glass are available in different colors, also in various configurations. And the transparency, it depends upon your requirement, that how much transparency do you need. You increase the transparency, of course, efficiency will drop. Then you can utilize the roof. The PV panels can be installed in the roof. And the balcony railings with graded DITVs. Then the canopies can also be utilized for DITV. Then the angle repair starts with integrated DITVs. And we can also use the walls of the building where we can attach or install to get a. So in this way, we can utilize almost all the available area of the building for energy production. So the global market size of the DITV is, the market size is expected to grow from 10.3 billion in 2021 to $12.4 billion in 2022 at a compound annual growth rate of 24.9%. And the market is expected to grow $38.4 billion in 2027 at a CAGR of 22.9%. So people around the world are investing in this business. 3 generations of solar modules, as I mentioned, at present, there are 3 technologies which are used for PIPV systems. The first generation is based on the mono and polycrystalline silicon solar panel. The efficiency ranges from 20 to 24%, but they are slightly expensive. The per watt rate is around 1.5 US dollars. Further, they cannot be used to replace the building materials. They can just be applied or attached to the building wall or roof. Also, the manufacturing process of the first generation panels for modules is very expensive, and they also generate high carbon emission during the purification of silicon. The second one is the second generation PV modules, which are based on the CIGS, gallium medium gallium selenide, the CTT gallium telluride, and the amorphous silicon solar modules. Their efficiency ranges from 12 to 19%, and they are used to replace the building materials such as windows or roofs. So you can say that this is best for the application. The third one is the third generation solar modules. They are based on organic photovoltaics and perovskites solar modules. Their efficiency is high, so due to their high efficiency and low cost, they are considered to be perfect for the PIPV. They are also low weight, and they can be printed on any pattern. So in that way, they are considered to be best for this kind of application. The perovskite tandem, perovskite silicon tandem modules are also available, commercially available. Their efficiency is much higher, but they are very expensive. So for BIPVs, they can be used, for example, if you want to integrate the panels on the walls. So as I said, the third generation solar technology is best for BIPV with low cost, beautiful aesthetics, working in cloudy and hazy days, and their performance is also better in case of partial shading. Manufacturing is quite simple, do not require any special conditions like the first or second generation PV technology. And they also reduce the carbon footprint around 5 to 6 times lesser carbon footprint compared to conventional. So these are some of the players who are working on the commercialization of the perovskite modules. And they have installed several power plants based on perovskite or perovskite silicon tandem in the world. For example, one of the pilot projects in Greece based on the graphene-enabled perovskite solar farm, and there are many projects, but I will include only 2 in the slides. The second one is in Poland, where the Soltech company have solarized actually the whole building using only perovskite solar panels. Now, in our sector, as I mentioned in the beginning, that one of the research group is also involved in the PhD research. So we have won 2 projects in this field. The first one is already completed. That is the 3rd generation solar PV prototyping lab. This project was awarded by the Higher Education Department, the government of Haiti, and the total grant was 3.7 million. And the objective was to establish a 3rd generation PV prototyping lab, and also to develop a carbon-based perovskite solar cell. This project is already completed, and we have successfully established the prototyping lab and also developed a perovskite solar cell around 12%. In order to take the project to the next step, we also won another grant from the Higher Education Commission. The project is on 3rd generation photovoltaics for grid integration, and the objective of the project is to develop semi-transparent solar cell and solar modules. Then in the next phase, we will try to develop the flexible solar cells and solar modules. And in the last step, the modules, both the modules, either the flexible or the transparent, will be integrated with the photovoltaic. So this is the lab. These are the equipment basically that we have purchased and developed a lab. These are mainly used for module manufacturing. And this is the cell that we have made in our lab, a 2x2 cell with efficiency of approximately 12.8%. The structure of the cell is here. We have electrocoated glass, and on this compact titanium, we are using importer or big printer. Then we have the mucopolis titanium, the zirconia, and the carbon. And the perovskite is infiltrated at the end to make a complete cell. Then the second project, as I mentioned, that we secure fund from the HEC, around 17.3 million, and in this project, we will be working on to develop a semi-transparent modules, flexible modules, and then integration of that. So far we have made a semi-transparent solar cell and solar modules of different dimensions. This is a 2x2 cell. This one is a 5x5 module. This one is a 10x10 module, and 30x30 module. The efficiency of the 30x30 module we achieved so far is around 12.07%, and this is repeatable efficiency. We have estimated over time. Our next step is to go towards near transparent perovskite modules. We have tested one module in the team here. So this module, we try our best to make it near transparent. However, the efficiency we achieved so far is less than 1%. Our team is investigating some advanced materials to enhance the efficiency of this module. Secondly, most of the materials used in the perovskite cells or the grid research, they are imported, so they are not locally available, and it costs a lot to import those chemicals. So we are trying to synthesize those chemicals locally in our lab. Secondly, we have successfully recycled the FeO for the glass, and that can again be used for making solar cell or solar panel. After achieving a reasonable efficiency, we will try to perform some reliability tests. These are around 9 reliability tests recommended for the perovskite solar modules, which includes the outdoor exposure test, the hotspot test, UV conditioning, thermal cycling test, humidity freeze test, the tank heat test, wet leakage current test, and the steady mechanical load test, and finally the head test. So after that, this is just a prototype building. Our prototype will be slightly different from this. When we test the efficiency and also the reliability of the semi-transparent and flexible tools, our last objective will be to integrate those modules to a prototype building. The semi-transparent or near transparent modules will be used to replace the windows, and the flexible will be used on the roofs and walls of this prototype. So the landscape of the PV panels in Pakistan, there is no local manufacturing of the PV modules, and about the some limited volumes of the panels are assembled here, but their quality is questionable. Customers are not satisfied with the performance of local panels. So we mostly import the panels, and import quality are also two types. The first one is the high quality panels, which is approximately 30%, and the second one, the low quality panels, whose percentage is much higher. This means that in Pakistan, in most of the areas, we have low quality panels. So we are trying our best to locally manufacture the third generation special modules, which however, it is very difficult to convince the government to give us, let's say, the budget for this kind of modules, the commercially available modules, very high. So it is very difficult for us to convince the government to support us to establish these modules in Shah. Apart from the PLDVs, we have also established a solar testing lab. This lab is, I guess, also available here in New Singapore. So from this lab, we generate some revenue, and we providing testing services to the government and private organizations. This is we have signed the MOU with the government department here, a Pukunpa Energy Development Organization, regarding the PV module testing. So we are mostly testing those modules which are installed in various government organizations. And in solar side, we are also providing some technical support to the government in the form of consultancy. Currently, we are providing consultancy services to the government in the project polarization of government colleges in newly merged districts of KP. The total work is around 1.43 billion. And secondly, in this second project, we are providing the services, the project land, polarization of government colleges, second area of total work is 1.7 billion. So this is what we are doing on the solar side. apart from that, other research groups or centers are working on smart inverters, lithium-ion batteries, and since in our province there is a huge potential of solar and hydro, so recently we have signed a MOU with a French company, and we will soon establish a micro hydro testing lab in our center. So that's it. Thank you.
क्या वो थर्ड जनरेशन की टेस्टिंग के लिए
इसकी टेस्टिंग
आपने अभी मेंशन किया टेक्नोलॉजी सेक्टर में टेस्टिंग ही होती है, इक्विपमेंट है, फ्लैश टेस्ट और
जी बिल्कुल
वही वाला इक्विपमेंट आपने यूज किया जो
अभी
आपने
यूज नहीं किया, वो करेंगे।
अच्छा आपने वो टेस्ट बताए थे ना, रिलायबिलिटी टेस्ट 9 टेस्ट के हमने किए हैं, वो भी परफॉर्म नहीं हुए?
वो भी नहीं हुए।
अच्छा
once we achieve a reasonable efficiency तब उसके बाद टेस्ट
आपके ख्याल में जो एफिशिएंसी 12.07 आई है ये इससे ज्यादा बढ़ सकती है?
एक्चुअली ये जो मैंने बताया, दिस इज कार्बन बेस्ड पेरिस्टाइड सेल और मॉड्यूल इज मोर स्टेबल। इसकी जो स्टेबिलिटी हमने लिटरेचर में देखा है तकरीबन 15 इयर्स। तो हाई स्टेबिलिटी मींस लो एफिशिएंसी। तो अगर हम एफिशिएंसी इंप्रूव करेंगे तो ऑफ कोर्स स्टेबिलिटी ड्रॉप। लेकिन since we are working on the standard transparency and we also trying to increase the transparency, increase करेंगे, then efficiency will of course drop.
और सर वो जो इक्विपमेंट है जो आपने पहले मेंशन किया था टेक्नोलॉजी सेंटर में 6.215 के अकॉर्डिंग है ना, तो वो तो कुछ साइंस रिकॉर्ड पर यूज के लिए नहीं है जो स्टैंडर्ड है IEEE 6.215, तो क्या वो एप्लीकेबल है इस जनरेशन के लिए? थैंक यू।
There is a certain angle. एक angle है something directly related efficiency solar की gain कर सकते हैं। लेकिन जब हम walls पे door के ऊपर window के ऊपर जब हम करेंगे solar panel तो उसका efficiency में कितना difference है?
अच्छा देखिए, फर्स्ट जनरेशन के पैनल में यह सिलिकॉन है और सिलिकॉन इज ए लेस एफिशिएंट मटेरियल। इसकी जो थ्योरेटिकल लिमिट है वो अप्रोक्सीमेटली आई गेस 30 या 30%। तो थ्योरेटिकल लिमिट मींस कि हम उस तक भी नहीं पहुंच सकते, इससे ज्यादा परफॉर्म नहीं। तो थर्ड जनरेशन के हैं दे आर एफिशिएंट मटेरियल, वो स्टेबल नहीं है लेकिन दे आर हाईली एफिशिएंट। तो जिस तरह मैंने दिखाया स्लाइड्स में, उनका ये एडवांटेज है ओवर द फर्स्ट जनरेशन और सिलिकॉन बेस्ड मटेरियल कि आप इसका टिल्ट एंगल जो भी रखें दे विल गिव यू मैक्सिमम एफिशिएंसी, वो पावर ऑफ ज्यादा है कंपेयर टू फर्स्ट जनरेशन, क्योंकि उसकी जो एब्जॉर्प्शन एफिशिएंसी है वो हाई है।
क्वेश्चन आपकी वो कॉस्ट कितनी आ रही है मैन्युफैक्चरिंग का? हमने प्रोटोटाइपिंग सिस्टम बनाया तो उस साइड से उसकी कॉस्ट आप अभी इसमें प्रोटोटाइपिंग में आप कुछ अंदाजा करेंगे किस कॉस्ट में?
सर वो एक्चुअली मेरे पास ये स्लाइड भी स्टूडेंट ने बनाई है, तो कॉस्ट एनालिसिस हमने की है, जैसे हमने 1 मेगावाट के लिए की, लेकिन अभी मेरे जहन में वो नहीं आ पूरा 1 मेगावाट। और उसके लिए हमने ये भी कहा कि कितना मटेरियल लगेगा, ज्यादा कॉस्ट मटेरियल का अराउंड 70%। फिर इसमें हमने लेबर को भी इंक्लूड किया, फिर लैंड की कॉस्ट भी इंक्लूड की, फिर इक्विपमेंट की कॉस्ट भी इंक्लूड। ये हमने पूरे बनाया हुआ है, तो मैं कुछ बात कुछ शेयर कर सकता हूँ।
मुझे कर ली क्योंकि अब पाकिस्तान में मैन्युफैक्चरिंग का इंटरेस्ट स्टार्ट हो रहा है काफी। इसमें लोग को कंसर्न ये शो करते हैं जो इन्वेस्टर हैं, अगर मूव होने लगे थर्ड जनरेशन की तरफ तो हम सेकंड जनरेशन में इन्वेस्ट करना आज, लेकिन वो इससे कितना टाइम लगे कमर्शियली ये वायबल हो जाएगा। आपने क्योंकि स्टार्ट किया, आप कर पाकिस्तान में थर्ड जनरेशन यूज कर रहे हैं, चैनल प्रोडक्ट ही आप कर रहे हैं। हमारे पास फैसिलिटी है जिसमें हम लोग सिलिकॉन बेस्ड हैं, 5-6 सालों से 8 सालों स्टूडेंट्स की ट्रेनिंग के लिए करवा रहे हैं। तो यहाँ लाहौर में शिकूर के आसपास रीजन में 3-4 इन्वेस्टर्स आ गए जो प्लांट लगाना चाह रहे हैं 500 मेगावाट तो फिर अब उसमें इसका कितना टाइम है कि कमर्शियली पाकिस्तान में बन सकता है कुछ वादा है इसमें जो प्रपोज साइट्स हैं सर
फिलहाल चूंकि यहाँ पे इशू ये है कि अवेयरनेस या ट्रस्ट जो है ना वो डेवलप करना काफी मुश्किल होता है चूंकि फर्स्ट जनरेशन जो टेक्नोलॉजी है वो काफी इन है मार्केट में तो थर्ड जनरेशन है वो भी कमर्शलाइज हो चुका है लेकिन सारी दुनिया में नहीं यूके में चाइना में यूएस में वहाँ पे काफी ज्यादा है इवन पोलैंड में है तो अभी इतने ज्यादा लोग इस पर ट्रस्ट नहीं करते आई डोंट नो सर मे बी लेकिन रिसर्च बहुत ज़्यादा हो रही है इसमें और ज़्यादातर जब हम ब्रांड्स को देखते हैं जहाँ पाकिस्तान में भी ज़्यादातर ब्रांड्स को पेस्टिसाइड बेस्ड सेल्स को बनाते हैं तो उनको मिलता है तो मेरे ख्याल में इन द नियर फ्यूचर ये जल्द होते इवन जो इन्वेस्टर की तरफ बात कर रहे हैं वहाँ पे देखेंगे कि हमारे कुछ इन्वेस्टर से बात हुई थी तो वो भी इसके पीछे थोड़े से हट गए कि अगर अभी हम लेट्स से फर्स्ट जनरेशन के प्लांट लगा दें तो ऐसा ना हो कि कल को फिर ये टेक्नोलॉजी खत्म हो जाए थर्ड जनरेशन तो हमारी सारी इन्वेस्टमेंट ज़ाया हो जाए तो इसलिए वो अभी वेट करें
ये बताइए कि थर्ड जनरेशन आप आपको बता रहे हैं उसमें आप एक चीज बताइए कि दे आर वेरी लीव प्रॉब्लम लेकिन ऑन द सेम टाइम दे आर वेरी स्टेबल तो एनवायरनमेंट के पॉइंट ऑफ व्यू से या आप अनस्टेबिलिटी है वो आप कैसे इसको एक्चुअली करते हैं क्या है और दूसरी बात ये कि आपने अपनी स्लाइड जो फर्स्ट जनरेशन सेकंड जनरेशन थर्ड इनके जो ऑब्जेक्टिव्स हैं फॉर द यूटिलाइजेशन कि आप इनको रूट टॉप के लिए इस्तेमाल करते हैं कर सकते हैं थर्ड वाला जो आप ऑर्गेनिक ये है ना जिस तरह के फॉर्म के अंदर आप उसको प्रिंट करें मतलब उसकी यूटिलाइजेशन है वो दैट माइट बी समथिंग कि जो मतलब आप बिल्डिंग के किस पोर्शन पे उसको लगाना चाहिए तो क्या ये इस तरह से हम उसको परसीव करते हैं कमर्शियली जब ये चीज है और से डॉक्टर साहब ने कहा कि अगर प्रोडक्ट लगेगी जनरेटिव एक प्लांट्स लग जाते हैं उसको आने शुरू कर देते हैं एक चीज ये चीजें है लेकिन जिसमें आपने बात की कि अवेयरनेस नहीं है तो उसके लिए क्या ऐसा कि आपके दिन में रोडमैप या ऐसी बिल्डिंग या का एडवाइजरी या चीज है कि इसमें जब लोग बना रही है छोटे स्केल पर लेकिन मॉडल या मॉडल बिल्डिंग कहाँ पे उसको
अच्छा आपका पहला क्वेश्चन वैसे है
पहले क्वेश्चन ये है कि जो आपने कहा कि स्टेबल है
राइट अच्छा सर ये चूंकि थर्ड जनरेशन का जिस तरह मैंने बताया कि अभी क्यों इतना ये फेमस नहीं हुआ या कमर्शलाइज नहीं हुआ बिकॉज ऑफ स्टेबिलिटी इवन मुझे 2-3 दिन पहले एक न्यूज़ मिली है क्रिस्चियन यूनिवर्सिटी ने अभी प्लान किया हुआ है आई डोंट नो 30 years स्टेबिलिटी तो विच इज कंपैरेबल जो हमारे फर्स्ट जनरेशन इवन सेकंड जनरेशन का भी प्लान कर रहे हैं तो स्टेबिलिटी का इशू है लेकिन ये सारा मटेरियल्स का गेम है क्योंकि हम जो काम कर रहे हैं वो कार्बन बेस्ड है हम डायरेक्टली हमारी कोलैबोरेशन है लॉन्च के साथ बेस्ड कंपनी है और प्योरली पेस्टिसाइड्स या थर्ड जनरेशन पैनल का काम तो उनसे हम थोड़ा सा गाइडेंस लेते हैं तो फिलहाल कार्बन बेस्ड जो हमने किया हुआ है दे आर हाईली स्टेबल और इफिशिएंसी हमने तकरीबन 12% अचीव की है लेकिन जो रिपोर्टेड है वो 13 के आसपास की तो अगर हम इसकी बिगेस्ट डिसएडवांटेज फिलहाल है वो स्टेबिलिटी का है लेकिन अगर आप स्टेबिलिटी को इंप्रूव करोगे तो इफिशिएंसी ड्रॉप हो जाएगी ये इशू है सेकेंडली सर जो आपने बात की है अबाउट द अवेयरनेस तो हमारे अपने जहन में ये है कि जब हम एक प्रोटोटाइप बना दें इस सेंटर में वी विल ट्राई कि हम ग्लास इंडस्ट्री और जो कंस्ट्रक्शन इंडस्ट्री है उनको थोड़ा सा अप्रोच कर लें उनसे बात कर लें उनको दिखा दें क्योंकि अभी ये स्मार्ट बिल्डिंग्स का कॉन्सेप्ट ये पाकिस्तान में भी आ चुका है यहाँ पर भी जो नए बिल्डिंग्स बन रहे हैं तकरीबन सारे ट्रांसपेरेंट है उस ग्लास को वाई नॉट हम इसके रिप्लेस करें तो उनके साथ हम बात करेंगे, इसी से भी हम आगे लेके आओ, क्योंकि वो थोड़े से स्ट्रॉन्ग लोग होते हैं, वो लिंक्स वगैरह जो होती हैं, तो आगे वो पेयर की बात करेंगे।
Just an idea. Like we are creating complex, right? So is there some kind of matter of example that can teach that method? I'm just kind of मतलब ये can be a smaller product. तो आप जो काम कर रहे हैं तो काम कर रहे हैं
तो वो तो सर इस तरह है कि हम लेट्स से कोडिंग कर सकते हैं, लेट्स से इसकी जो क्या बोलते हैं, तो एंडर्स वगैरह यहाँ पे कोडिंग क्लास पे हम नहीं कर सकते, लेकिन बाकी जगहों पे हम कोडिंग कर सकते हैं, लेकिन दे की वेरी इनएफिशिएंट, तो वो कम आपको पावर। वैसे दुनिया में तो ऑलरेडी आ चुका है, सोलर बैग्स भी हैं, सोलर क्लोथ्स भी हैं, हाइब्रिड व्हीकल्स हैं, सोलर को यूज किया हुआ है, वेरी थिन फिल्म
मैं स्पेशल बात करता हूँ क्योंकि there is a special company I cannot recall the name, actually वो upload Zoom focus intensive काम कर रही है, they have the class in the world जो आप foreign year actually automatically focus करती है adaptive use, तो उस टेक्नोलॉजी के साथ अगर आप इसको शेयर करेंगे आप आपकी नॉलेज में है क्या क्या
बिल्कुल आपकी बात ठीक है, लेकिन इसलिए थोड़ा सा ऑफिस का नॉलेज भी होना चाहिए।
मेरा क्वेश्चन है, आप सोलर टाइप पे इसमें जिक्र किया था कि हम सोलर रूफ, so what is about that? How we can make solar roof faster? As you have mentioned that only Tesla and some companies we have made previously are virtually common. So how we can introduce in Pakistan?
सोलर रूफ पैनल्स मेरे ख्याल में पाकिस्तान में यूज नहीं करना चाहिए, बिकॉज कॉस्ट इज वेरी हाई। यहाँ पे चूंकि हमारी रिक्वायरमेंट ये हुई है कि हमें एफिशिएंट एक प्रोडक्ट भी चाहिए और उसकी कॉस्ट भी कम होनी चाहिए, तो हमारी तो ये रिक्वायरमेंट है। सोलर रूफ टाइल्स में उसका जो सबस्ट्रेट होता है वो वही जो आम टाइल हमारे पास होता है वही होगा, उसका शेप आप जो सा भी बना दें, चाहे वो साइनसाइडल फॉर्म में हो चाहे वो प्लेट, उसके ऊपर लेट्स से हम अगर मैं सेकंड जनरेशन की बात करता हूँ तो एमोर्फस सिलिकॉन की कोटिंग कर लें, दैट कैन बी ए सिलिकॉन फॉर द टाइल।
This is the class from the Center for Energy Research, UT Lahore. इसमें आपसे ये पूछा था कि जो थर्ड जनरेशन के सेल्स हैं या जो सिस्टम आप कह रही हैं, इसमें जो मटेरियल रिकवरी साइकिल है क्या वो पॉसिबल है? जिसका फर्स्ट जनरेशन के अंदर हम सिलिकॉन जो पैनल से अपनी एंड ऑफ लाइफ पे पहुंचते हैं तो उसको क्रश करके उसमें से मटेरियल को रिकवर कर सकते हैं, तो क्या इसमें कितनी % पॉसिबिलिटी है या क्या इसमें कोई काम हो रहा है? अच्छा,
इसमें जिस तरह मैंने एक फ्लो कोटेड ग्लास की बात की, ये ग्लास भी क्योंकि हम बाहर से मंगवाते हैं कुछ भी नहीं होता, तो इसके हमने जो अभी जो बनाया है तो वो उसमें कॉम्पैक्ट टाइटेनियम और सुपर टाइटेनियम वगैरह उसको हमने सक्सेसफुली रिसाइकल कर दिया। कॉम्पैक्ट टाइटेनियम को रिमूव करना इंतहाई डिफिकल्ट है, लेकिन हमने उसके ट्रेसर में चीज़ें पढ़ी और फिर हमने कुछ रेसिपी वगैरह इसलिए डेवलप कर दी, तो उसको बहुत ज़बरदस्त तरीके से रिसाइकल कर दिया और उसको फिर टेस्ट भी कर दिया कि उससे हमने दोबारा एक सेल बना दिया और एफिशिएंसी मोर और लेस कंपैरेबल आ रही थी उस ग्लास के मुकाबले में जो रिसाइकलिंग थी, तो रिसाइकलिंग तो हम कर रहे हैं वहाँ पे। और जो मटीरियल्स की बात आपने की तो वो पेरिसाइट itself जो थिंक है पेरिसाइट थिंक ये भी बाहर से आता है और इसकी कॉस्ट भी काफी ज्यादा है, ये भी हमने खुद बना दिया, टेस्टिंग हमने कर दी, रिजल्ट्स थोड़े से हमारे तो इसकी केस से कि जो एफिशिएंसी है वो थोड़ी सी कम आ रही है उसके मुकाबले जो हमने बाहर से इंपोर्ट किया, लेकिन फिर भी हम कोशिश करें कि इसको बिल्कुल स्टैंडर्ड के मुकाबले दिया।
Thank you so much.
Thank you so much, Dr. Tao, for your informative talk. So the title of our next funded talk is How Can We Achieve Zero Waste and Circular Economy in Pakistan by Dr. Abdul Sattar Nizami. Please welcome Dr. Abdul Sattar Nizami. Give him a round of applause.
Sorry, I also have to ask the question. Then I thought may have to solve question again. Then you have to talk the time on again. Any questions later on? So thank you once again to all of the advisors, first of all, for inviting me again. Very prestigious and very effective conference. So I'm going to talk about today about the zero waste concept and circular economy. आप इसको visualize कर सकते हैं एक ही point के two phases हैं. If we talk about the circular economy, it means we are going to achieve zero waste concept. Or if we make our strategies in such a way that we want to achieve zero waste concept, we are heading towards achieving the concept of circularity, a circular economy. I'm pretty sure all of you know there are different models of economy. Let's say linear economy, उसको fossil fuel economy कहा जाता है, non-renewables होती है. उसके अंदर आप जितने भी जो raw materials हैं, virgin materials हैं, resources हैं, उनको extract करते हैं, mine, and then you utilize them, and then ultimately they basically end up. While in circular economy, you always consider कि जो आपकी raw products हैं, waste products हैं, at the end of the day, या आपकी जितना भी वो process है, उसकी manufacturing, उसकी production, उसकी utilization से लेके end life तक, all of them are considered reusable or recycled materials, and we try to bring them back into the loop. So basically, there's no waste anymore in the concept of circular economy. And obviously, when we have tried to achieve the concept of circular economy, particularly in developing world, in our context, so we are going to achieve not only the zero waste concept, but nowadays, like a very famous United Nations SDGs, Sustainable Development Goals, not one or two, several SDGs we can achieve with this concept. So this is the linear model. We know linear economy, as I said, raw material extraction, production, utilize, and wastage. That's how we are opting. It's being practiced in all developing countries, even in Pakistan. While in circular economy, at each phase we consider what leftover, unwanted materials, waste materials, we try to utilize them by different schemes through recycling, reuse. There are different concepts. So if we want to move from linear economy towards circular economy, in between there's a chain economy. In chain economy, we basically try to bring the new resources. Okay, we have a cycle in between among the production, consumption, and downcycling, the waste utilization. And still we are producing waste somehow by any process, in any of the phase. But in circular economy, we have this concept where we consider very closed loop, and we consider everything like we cut all of the raw material utilization and utilize them, move them in such a fashion or manner where we reutilize them and utilize them again and again, depending on the raw materials we have. So these are the different, when I talk about the circular economy, there are different principles, methods, objectives for circular economy. This is how we judge that this country is achieving or near to circular economy, or circular economy is already implemented in that society, region, or city or country. So obviously, in circular economy, we want to have a constant source supply of renewable, recyclable, and biodegradable resources because we give them a value. They are not waste anymore. So we focus in circular economy, the elimination of material leakage, and we give a value to the resource recovery principle. And then we consider the extension of the current life cycle of products. This is very important. Then we share the different platforms. Products users, we have multiple users. So we can say, okay, this product or waste is not utilized in one process or one phase can be utilized in another process. Then the products as a service. And then obviously the green environment is very important nowadays in the context of climate change. So circularity or circular economy has become a gateway, you can say. If we want to achieve SDGs, Sustainable Development Goals, or want to achieve the sustainability, inclusiveness, circularity in everything, like in sustainable, if we talk about sustainable consumption, sustainable production, sustainable utilization, everything. There's a famous 12 SDGs. It directly talk about the responsible consumption and production, and it integrate, connect directly, indirectly, one way or the other, rest of the SDGs, where we are trying to have the affordable and clean energy, where we want to have sustainable cities and communities, clean water and sanitization, climate change action plan, decent work and economic growth. So basically, there are three triangles like it. We want the prosperity of the society, we want to progress economically, and we want to have a better environmental condition of health and safety. So if we have a circular economy, that means we are going to achieve the zero waste concept in a way, because we are trying to cut the extraction of the raw materials in the form of forest trees. We have fossil fuel, everything we have, and then at the end of the day, when we have produced a linear economy waste, we either have a landfilling option or incineration or other option. We consider them like they are not water friendly, they are cost intensive process. So we have like this production where we trying to relocate, reuse, recycle all of the waste we have. And this concept of R's, I'm pretty sure all of you know, the 3 R's, reduce, reuse, recycle, then there are 4 R's, 5 R's, 6, 10. It goes till 10 R's, even beyond that. So there are 9 R's of circularity. If we want to achieve the zero waste concept, obviously the breakdown is according to the demands and need and requirement of that society where it wants to implement. So obviously all of these principles are concepts will contribute a share, a percentage wise, to bring back the waste materials. Refuse, reduce, reuse, repair, repurpose, reuse, remanufacture, recycling, recovery in the form of energy or value-added products. And even before going beyond toward the recycling, we have different R concepts like it. And all of them are very important in a way, because we have said that we want to have a circular economy, we want to have zero waste. So we do not want to see waste anymore. So what we should do basically? Then we have to consider all these steps. Ultimate objective, obviously, we want to have a zero waste lifestyle. It's not about something management issue, it's not about the administrative issue, it's more about the attitude, more about the perception. So you always ask this question, research student. If you are sitting like we are producing tons and tons of waste, and we are not going to stop it. We will continue it with our population growth, urbanization, all of the reasons we know. And then we are producing the mountains of waste. In Lahore, if you remember the previous landfill site, Mahmood sites, we have like if you go to the ring road, if someone do not know, he might say there's mountains here. If you go to the GT road to Gujranwala, you will see the mountains. So these mountains are basically the waste mountains we have. So the amount we produce, obviously, it's like a yearly basis is estimated or like anticipated If it is pile up all of them, we have a double height of the table, like the waste we produce. So this is the one scenario. It's a linear approach, linear economy. We produce the waste and then we waste the waste, basically. So what we should do? So obviously, as a researcher, scientists are young students. We shouldn't be panicked or shocked. There's no solution. It's something very like ugly. We shouldn't be. We have to be more opportunistic. Is what it is. We have to be more opportunistic. Let's say I always say if you're standing in front of a garbage bag or cats are like beside you, who are like the more opportunistic? Obviously, the cats are because cats see a garbage bag in a completely different way, but we perceive about the waste. So we have to change our perception. So this is zero-based lifestyle. It's more about the attitude. And this is not something like if you can say like something illusionary or dreamy or cannot be implemented, cannot be done, something like it has to be only education in the way that no, it has been done. The countries have shifted from landfilling of their waste to other, divide all of their waste to reusable or something resource materials. For example, the UK they have a landfill directive back in 1560s, and then they gradually and slowly they shift from the landfilling towards like a recycling, towards energy, other process from the waste. And what they have done, one thing is very like important. They stop or ban the words waste. They say don't write this waste keywords because when we write the waste, it's something like it's hit with our mind, like a perception or attitude. Something looks ugly, dirty, smelly, or like problematic, challenging, like this all different bad names. They say, okay, you can use the terms recycled products, green products, metallic products, Harris-like products, tradable products. They have used these terminology basically. The first thing is to change the people's mindset. Okay. They say if it is changed, then it's much easier for us to introduce the rest of the things. Okay, you can say the waste is no more than what it is then. So they say it's a trigger, it's a bank, the economy, revenue, dollars. It's everything you can say other than the waste. So obviously, if we manage our waste in a sustainable way, adequately, wisely, we could not only produce one value-added product, we can have a range of products. And those range of products could be energy, could be power, electricity, could be heat if we need, can be food for humans, can be feed for animals, can be compost, organic fertilizer, can be a source of chemicals. So you could have a range of value-added products. So obviously we are going to valorize our waste. So there is another challenging point. I didn't want to talk more like it. There are certain, I'm sure, as engineers, you know, there are different waste energy technologies. They are broadly categorized based on thermal, non-thermal. Thermal are classified as incineration, could be pyrolysis, could be gasification, plasma or gasification. On the vice versa, other hand side, if we talk about the non-thermal, we have anaerobic digestion, we have a fermentation, we have MPT, we have RDF, refuse dry fuel. So the point is, at the end of the day, nowadays, as we ask many questions to our brother fellow, the economics is very important. Like for investors, for business model, for policy makers, for everything. At the end, they ask how much the money is required if you want to have this plant, and then tell us the amount in terms of how much the electricity we are going to produce from waste to energy, one unit, how much the charge we have to pay. At what tariff rate we have to set to the public, how we are going to set all of different price. This is very important. So we obviously, as a scientist, we have seen the success stories of waste to energies in so many countries. For example, Germany is leading. For example, I always say is anaerobic digestion. The thousands and thousands of digesters, anaerobic digesters are running very successful. Austria, Denmark, Norway, Finland. But there are reasons. There are certain reasons why they are successful or why they have increased the share of renewable energy in their energy mix. Because it's very important to have the energy mix for our. I will tell you, unfortunately, our energy mix is not sustainable. We're heavily relying on the imports of oil and gas, LPG, and then we produce electricity. So, and rather than like increasing the domestic sources, indigenous sources like solar, like a waste energy. So this is very important. So if they have increased the maximum so far, the contribution, the Denmark have a leading success. So they have successfully 20% of the renewables are contributing to the energy mix of the country. So how they have achieved success? Obviously, we always talk about the political will, the government heavy subsidies, but there are other reasons. Public-private partnership is there. They have incentivized, they have tax exemption. If the car is running on biogas, there is no tax, it's tax-free. The parking will be on priority basis. If you are recycling, go to the market, you have a recycled bottle, you can get some honorarium in terms of cash money, you can like it, give the pay, you can deduct into your grocery bill. So there are so many other things you can do. So there are limitations. Inherited limitation when we talk about the single. If we talk about the incinerator plants, the Lahore, it was almost done with different, like a Chinese government, French government, they are here to develop, and then the COVID came, and then they ran of everything, and then they went back. So the problem with the single waste energy, obviously, if we want to compare it with the other renewable system like solar, like wind, they are not so efficient. Their conversion efficiency is still very low. Economics are so far are not very favorable, not good economics. Yeah, it's still expensive. But obviously, it's like a dual benefit. On one hand side, we are producing electricity that is expensive as compared to solar, as compared to hydro. But on the other hand side, we are going to solve the waste-related issues that itself are such a giant or magnificent in our countries. And in developing countries, they have like it's only the open landfilling. Let's say Pakistan in Lahore, landfill around 8 million tons of waste is produced only in Lahore daily basis. All goes to the landfill side, and more than half of them is degradable. The food waste, combustible waste is degraded anaerobically. So its result produces methane, and methane is 20-40 times more dangerous, harmful as compared to CO2. So this said that only the landfilling practices we have in developing countries are responsible up to 60% of the climate change of that particular country. So you can imagine how big problems we have on the other hand side. And the other issues, obviously, the economics, land acquisition, transportation, logistics, all others are there. So obviously, these single waste energy are still not cost effective, still energy intensive, labor intensive, and the labor sometimes very skilled labor are required. Sometimes other economics are not favorable. If the government is not going to subsidize the trust deficit between public-private partnership, investors, all these things. So my research team back in Canada and Saudi, we proposed this model. So this is very pioneering and unique model, still hypothetical in a way. So biorefining concept. So this concept already exists in a different way, but we completely revamped this concept. So you know the concept of oil refining. I'm pretty sure as an engineer you must know. So you basically the basic concept you brought like extract the crude oil mix, and then through distillation, different temperature, pressure, you have a range of products from one product. That crude oil gives you a range of value-added products. So similar concept we apply in biorefining concept. And the biomass-based biorefining, somehow many scientists like it, they have already elaborated. There could be a potential for lignocellulosic waste, biomass like a citrus-based food waste. So if we consider biomass, we can say the carbon recycling, eco-friendly, these are the benefits. Food security, declaring of resource shortage, We can have, if we have obviously petroleum is a diesel quantity waste, energy intensive, expensive feedstock, like still we do not have oil, we always imports, depend on the countries, greenhouse gas emissions, toxic byproducts. So we gave this concept, the zero waste biorefining or waste biorefining concept. And we're saying in your country, in our city, we have something which is like a already economical burden on us because we do not know the value in it. We didn't realize the revenue in it. That's waste. That's either way we will produce. And either way it's going to be landfill site. So why it's actually landfill? We need to divert that waste to somewhere. And that's where biorefining. It's like a factory-like concept. It's a one roof concept. And we say bring all those waste at one place, and then you always have a MRF, material recovery, material recycling facilities, and calculate the waste, all of the estimate the numbers, and then see which technology is more suitable, and ultimately integrate them in such a way that it become a holistic factory. I will show you later on about this concept. And then ultimately you don't need to have any surplus electricity heat from outside. One process, if let's say if we talk about anaerobic digestion need heat, process clarification need electricity. So the end products of one process can fulfill the requirements of another process. So it's like an integration approach. So waste biorefineries are nowadays have become integrated, and back in like in 2014 and 15, we introduced this concept. We hypothetically calculated and we applied this concept very successfully. It's by huge success in Saudi and national, international. We pick up like a city, as we always feel very blessed. Makkah al-Mukarramah is very important from religious point of view. Millions of pilgrims come every year from Hajj Umrah. So they have an unusual waste traffic, waste production trends, especially Ramadan month or during Hajj time. And that's like a waste composition is very uncertain, unusual. It's not something like you can compare with any rest of the country. So we proposed this model for them, and we gave them the solution that we can solve more than 80% of your waste. Let's go to the landfill side, some waste biorefining, and you can have amazing economic, environmental benefits. So if we develop these waste biorefining, so we can achieve not one of many sustainable development goals, SDGs. Climate changes that actually hit climate change, public health, circular economy, sustainability assessment, indigenous community, knowledge sharing, waste valorization, sanitization, net zero carbon production, waste to energy. So here is that concept I was telling you. You have all of the waste in one place, you segregate them. Okay. This concept is very suitable for our country. We do not have a segregation network. We mix all of our municipal authorities, rest of the waste, and then we have MRF facilities. We take off, for example, the food waste, organic waste. We take all of the liquid one side, solid one side, liquid goes, for example, anaerobic digestion. We have biogas, and this all depends on the needs of the country. For example, if we do not produce electricity from the biogas, we need transportation fuel. Yes, it's true. Then we have a biogas, we can upgrade that biogas can be used as a CNG, like compressed natural gas. I don't want to go into chemistry, but and then we have a RDF, it's like a solid pellets fuel, substitute of coal. Then we have a process purification where all oil contents, animal fats, juice cooking oil can go randomly process purification. So CFP plants we have. So you can see the heat or the electricity of one process can be utilized as a requirement for the other process. Benefits unlimited. So many R&D for that country, solving waste problems, minimizing environmental pollution, and they are like this, in developing countries. Unfortunately, they are not quantified in terms of public health. We know primarily the waste landfilling cause air pollution, cause nature, soil, water pollution, soil pollution, but it's go beyond the health cost. We didn't quantify the health cost of the waste practices we have. We calculated this impact in Saudi Arabia, and we got amazing result in May. They have like every third person, they have different life pattern, lifestyle. Obviously, being more economically rich, they have like a lifestyle has been changed over the years in Gulf region, particularly oil producing countries. So they become very like almost lazy but different lifestyle. And then it's like every third person in the country have a diabetic patient. And the diabetic too is now directly scientific evidence is very much linked with the stress environmental conditions you live in. And then we calculate, and Saudi Arabia was like one of the top countries in the world who pay billions of dollars every year importing the medicine just to treat the diabetes. Obviously, there's no treatment, but just to cure or to maintain the health. How much the cost the country is paying is one of the world top billions of dollars every year. So, and we link those reasons for diabetes to clearly with the air pollution, indoor air pollution, with the waste management practices they have. Obviously, the other lifestyle patterns are there. So you can say it's not only about the waste problem or waste issue or climate change and greenhouse gases. It's more than that. The public health is very important. We know like in Lahore, the smoke issue. Like smoke, like in summer season, there's no spring anymore in Lahore. So these things are happening. It's not all of a sudden being happening or climate change is causing these, but obviously if we talk about the triggers or the causing factors, they are these factors are there. So new business, job creation, if we have all these benefits on one hand side, the public health definitely will improve. So I was giving you the example of Makkah City. So we did studies over there, and we calculated the categorize all of the waste in Makkah City, and we calculated around 88% of their mixed or solid waste is very much suitable for different waste to energy technology, while that 12% is very suitable for recycling. And then obviously the glass, cardboard, metals, aluminum have more recycling value, more money, revenue. And we break down these numbers, like we build a factory for Makkah City, and then we gave all these numbers, business number, economic numbers, benefits number, how much that you have the landfill like a divergence. Obviously, having the new landfill need more lands, and it's a big issue now in Lahore. The Mamoon Booty site has been closed because there's no more now the waste is going to look for here, another side, towards the store, the other side of that. And it's like they thought the capacity could be 10 years, the waste being produced, this is gonna be reached to full capacity in next few years. Means now we have to go another side. And that side, we are talking about not 1 acre or 200s of acres of land. So obviously that's cost money. So that's the saving. Obviously, we are like trying to save the fossil fuel utilization, oil saving, gas saving, huge saving, and then the saving, resale value of that energy. So we calculated, I have all these numbers and we published them, and all of my publications are publicly available. So just to give you the insight, so we calculated around 88 million Saudi riyals only from carbon credits. We break down all these numbers, the very detailed business sheets we developed. Around 758 million Saudi riyal can be generated only from landfill diversion and electricity. And there are other breakdown, and we calculate like obviously if you have this waste to energy and produce electricity, power, heat, other kind of resources like and compressed natural gas, it's gonna save all of the millions barrel of oil. That's basically we are trying to replace, recycle. Now think of the circular economy I was telling in advance. And that saving is around 485 million Saudi riyal. And that's still like huge millions of dollars if you convert that. So energy demand in Pakistan is not very good at the moment, and it's towards decline actually, unfortunately. It's not, over the years we have seen the energy mix is not very good. We have surplus indigenous resources, but we are paying less attention towards our, rather than generating or creating our own. I'm pretty sure like solar, the initial speakers have talked about, and if like investors or somehow we can break through, build a small factory, it's not gonna cost us billions of dollars. No, it's not that expensive. So, but obviously eventually we can stop the imports of solar panels from China, from Turkey, from European countries. We can have our own solar panels. And then this is how we can improve our energy mix. Rather than relying 100% fossil fuel and unfortunately import of fossil fuel. Because this is gonna cost us like it increase the cost many times if we have our own, and then unfortunately we do not have a sustainable solution accordingly actually. You remember we have a surplus, okay, gas reservoir, sweet gas. And then we have unsustained decisions, policy makers, they make a decision. And we were putting our that precious gas, that's the only source, into trucks, into buses, and everything. And what happened, we all know. Then we have to stop everything. And then we have a CNG station more than the petrol, and then we switch everything around. That was like a big collapse in terms of when we say our policy and decision maker are not technically, they are not like a sustainable decisions if we are not making them. We are producing, let's say, electricity from kerosene. So I don't want to say a big word, but like it's very expensive. We have this energy security action plan, Vision 2030. It says it's good to have at least we have something at least even in paper. So it says that we need to have a constant supply of energy. We have to promote, develop our indigenous sources. So we can like a shift from fossil fuel to renewables, and we can have all those benefits, environmental benefits, carbon reduction, climate change reduction, greenhouse gas reduction. A month ago, I presented this case study in National Textile University Circular Economy. So we can have this concept of circular economy, zero waste economy in each sector of our industry as well. We can have that. We can have it. The world have it. So there was example like in UK, how the UK is doing, for example, about the fabrication of the textile, and they are doing great, and they are like earning huge just by recycling of the clothes. So coming to conclusion and recommendation, these are very important actually. So when we talk about these concepts like sustainability, inclusiveness, circularity, we need zero waste concept like this kind of like our renewable energy. These are multifaceted phenomena. These are not like a single solution. We have to integrate different stakeholders, different parties, SMEs, small, medium enterprises have to come together, investors. So it's become more like a challenging, tricky, difficult. So this like not a single bullet solution. So we need to have more holistic and sustainable solution at that. Because different things are integrated together. So, and we over the years, not us, but the world have seen, I just quote you a few examples, how bad decisions we have made, unsustainable decisions. I can quote dozens of such examples. So basically, what we make a decision, whatever the reasons are, and then we, as a result of that decision, we realize that, okay, by solving one problem, we end up another big problem. And that's more difficult to handle than the previous one. So where we have to go, step back or move forward. So obviously all of these things need a lot of attention, dedication, innovation, invention, investment. As an academic person, a researcher, there are like I train my students training like a different, there are tools, scientific tools who validate your product, validate your process, phenomena, mechanism, whether it is, for example, this LCA, life cycle assessment, or life cycle impact assessment, or life cycle cost analysis, or social life cycle, this remote control. So we do LCA for this. Ultimately, we end up to know that whether this remote control is economically affordable to build or start or manufacture, whether it is environment friendly, eco-friendly, because by producing this or by manufacturing this, how much the share of CO2 we are going to reduce, and then it's socially acceptable. It's not going to cause any harm or issues to the public. So product space model, these are different techniques. So that has to be done. Sometimes this is very important actually. My area of expertise is waste to energy. I have seen so many failure examples, that success examples. I met all of the RODA, LWMC, the Lahore Waste Management Directors, and I have seen why your project so fascinating failed at the end of the day. The reason is they do not do what they consider is very basic. They say we know the waste, we know the quantity, we know. They didn't know the exact or accurate things. So these are called. So these scientific tools can help a lot in determining those things. We need to have a legal framework and national guidelines. This is very important nowadays. EPA or EPD is putting much stress or emphasis that our industry do not have an industry-specific NEQs. We have a standard NEQs, but that's not correlated with the industry-specific. Obviously, each industry has its own requirement. One industry process efforts could have a high COE. So if we ask that industry to cut like have the CO2 in that rate, it's not economically possible, feasible for that industry. So we need to have collaboration, academia, consortiums with industry. So it's not only industry or academia, industry, but also with the community, but also with the policy and decision makers, technological intervention and public-private partnership through trust, through confidence. Is very important. So few months ago, I wrote this report, very extensive UNEP for UNEP West Asia, waste management outlook for West Asia. I have talked all about the waste to wealth. So it's publicly available. You can read it. My established national international collaborators. Thank you so much. If you have any questions, you can ask. Unfortunately, so far we do not have a waste management, even action plan or policy that exists. We have a guidelines. That's vision. Vision or guideline is something very different. It says you okay. We need to have a recycling in our country. We need to reduce the waste. We have to create more education and awareness. But how? Yeah. There's no such legislation, there's no policy, or we didn't materialize, channelize how we have to implement those things. It's still a big gap. And even like LWMC, it's like these kind of Lahore waste management companies, but they are third-party companies. Their role, although they are the public, but their role is very limited in the way they are third-party who take like took the budget from the government, and the only responsibility is just to collect the waste and dispose. That's the logistics kind of operation, but you're not driving the real value out of it somehow. But there are the good thing, but that's need to be shifted actually. Over the years, if you know the economics in Lahore, it's very amazing, shocking. In Lahore, the recycling market. But all of the recycling that's being carried out in Lahore in Pakistan is illegal, informal recycling. There's no legal or formal recycling. There's no check and balance. There's no framework, regulatory body. Illegal way is a big market, and that market is of daily basis. They earn like a kabadia, how the waste being illegally all collected, waste pickers, scavengers. Thousands of families are earning their daily wages, and it's like a millions of work everyday revenue is generated. But that's okay, that's good. But our point of as academics or scientists, we say because the poor families, like small kids, they go as scavengers and they pick up the waste in more unhygienic way. There's no PP, personal protective equipment. So if there's a check and balance, all of this market can be regulated. There's a big, the scam often come on the social media, TV, hospital waste, for example. How illegal waste being all of behind the scene is being recycled, and then like illegal way without following the standard. There's no NEQ specific, even standard international. It's all being recycled into the same syringes, same bags, blood bags, everything like a tubing, all of things being done. And with the animal intestine, how they are being illegally converted into so many things. I do not want to name even the cooking oil.
So is there any, what's the nearest example, just Asian or South Asian region where, you're making up this here and like the developing countries like Pakistan, for example, Bangladesh, from Nepal or India, maybe something.
Obviously, we cannot compare China is near to us, but they are doing like they have this waste energy plant in each small town in it, small town district, each province level they have this. India is like a have problems melting tremendously as compared to us, even Bangladesh, about the recycling. So I just gave you the example of textile. There were other speakers who were telling how Bangladesh is amazing over the years have improved significantly in textile industry, and the recycling of the textile waste is must be appreciated. And we become like we were once in the top ranked country, now we are in the 2030 the list.
It's a wonderful thought. Okay, just wanted to ask, is there any possibility of introducing biorefinery concept in curriculum? We have a subject taught in this area. The energy department itself, like you mentioned, the agency is on, they're still struggling, like you mentioned, that the cost of energy from waste is so high, and they are trying to energy generation project, which it is actually environmental project, and you're trying to convert waste into energy. We take it as a cost for cleaning the environment, not paid as a cost for generating electricity, because it can never be in a comparable mode. So there is a lot of I think confusion, also misunderstanding about the cost of managing waste is actually required from an environmental perspective for identifying the living. So it really costs for all the gas costs which you pay, or whichever way which you pay. So that cost should be transferred into the clean environment that we're in. Somehow this concept needs to be that cleaning higher level makers there so this has to be cleaned up somehow. So I think most of us in curriculum level interventions are
yes, exactly.
Not only in the chemistry or chemical or
yes, fully agree. I like over the years, earlier on, at least start academics person, they always say, okay, we need to have a education and awareness. I'm sick of this now. Always thinking education awareness, education awareness. That's part of the solution, not the ultimate solution. It do not provide a complete solution. If we say another scenario, the top has to change and then trickle to the bottom. That's also a wrong approach. Because that's why I say it's very like a integrated approach, holistic approach, maybe a sustainable approach. Education awareness is very important, but obviously, if someone says like, I want to recycle or segregate my waste, okay, but obviously, what happened when the garbage, my waste is being collected from my door, is all mixed together. Then there's no like price value. So it needs to be like I see this like it need to be completely change all of the sectors, education, awareness, education, and part of the curriculum, as you said, has to be and training, volunteer activities, campaigns, conferences, so much. Yeah, thank you so much once again.
Thank you so much, Dr. Nizami, for informative talk. Now, I would like you to call Dr. Nizami to give the awarding sheet to Dr. Adnan Daud. Please give us the round of applause. Please give us the round of applause. Now I would like to call Dr. Bakar to give a word to Dr. Rani. Thank you so much for transportation management.
Next session after break,
Yes, sir. Thank you so much.